began waking up in a place where nothing should wake. Comets remain silent until sunlight warms them from the inside out, until they drift close enough for ice to crack and vapour to escape. But this object, 3I Atlas, began exhaling long before the sun should have touched it. A plume of gas emerged from its surface in the deep cold, a plume so strong that sensors detected a strange imbalance. 8 parts carbon dioxide for every 1 part water. No comet in our system behaves like that. CO2-driven activity belongs to the far frozen outer reaches, not here in the quiet midlands of our solar system. And before we go further, make sure you're subscribed, because this story is changing by the week, and you'll want to follow every new twist as it arrives. The coma that formed was extraordinary, a vast pale sphere of gas expanding outward until it reached nearly 350,000 kilometres from the nucleus, a structure so large that if you placed its centre at Earth, its breath would brush the moon. It glowed faintly against the dark like a lantern too old to understand it had entered a new night. Researchers stared at the measurements in disbelief. The numbers didn't lie. The object was awake, and it was awake too soon. When its trajectory was fully calculated, the truth settled in. This wasn't a child of our sun. Its path was hyperbolic, open-ended, a curve with no intention of returning. It came from the outside, and when it leaves, it will never be seen again. They named it 3I Atlas, the third confirmed interstellar visitor in human history. But unlike the first two, this one didn't hide behind ambiguity. It didn't shimmer strangely like Oumuamua, leaving arguments in its wake. It didn't behave like Borisov, whose icy heart broke open in the warmth of our sun. 3I Atlas announced itself immediately, long before crossing into the inner system, as if eager to release something it had carried for a long, long time. The James Webb Space Telescope was among the first to listen. Its sensors traced the signature of the coma, carbon dioxide dominating, water trailing behind, with minor hints of carbon monoxide and ancient ice grains embedded within the sunward plume. These weren't the fingerprints of something forged near a small, calm yellow star. These were signatures of cold-born chemistry shaped under a different sun, in a region where CO2 freezes into cliffs and layers and ancient reservoirs. Models suggested a birthplace somewhere in the thick disk of the Milky Way, where molecular clouds compress and freeze in ways our solar system never experienced. 3I Atlas had been wandering ever since, drifting star to star, system to system, until finally it crossed paths with ours. Its speed alone confirmed its origin. At closest approach to the Sun, it would reach nearly 68 kilometers per second, so fast that nothing we've ever launched could dream of catching it. Fast enough to cross the width of the United States in barely a minute. Fast enough to slip through our solar system the way a single thought slips through a dream. But it didn't simply pass silently. It interacted. It breathed. It responded to sunlight like a creature sensing warmth for the first time in ages. The early outgassing puzzled researchers most. Carbon dioxide sublimated fiercely at distances where water remained locked in ice. That meant its interior was layered differently from any comet we've ever studied. The CO2 wasn't mixed randomly with dust. It was concentrated, trapped in reservoirs built under another star. And as it moved, the release became directional, almost sculpted, leaving faint arcs of material pointing toward the sun. These arcs weren't aerodynamic or artificial. They were geological, frozen memories of an object that formed in a place too cold, too alien for Earth's chemistry to fully mimic. Then came the gravitational close calls. 3I Atlas would pass near Mars, then glide through Jupiter's vast influence like a thread of light brushing the edge of a planetary storm. For a moment, mission planners considered whether Juno could be redirected for a glance, but the numbers didn't allow it. The object's speed was unforgiving. Jupiter's gravity would barely tug it. At best, it would bend the trajectory by a fraction. At worst, change nothing at all. But the solar system still left its mark. The tail, faint at first, responded to solar wind with the predictable grace of a natural body. It stretched outward, always pointing away from the sun, shimmering with dust grains too small to see individually. Nothing artificial lurked within that tail, nothing mechanized, just ancient material carried from a star humanity will never see. And yet, something about it didn't feel familiar, not threatening, not dangerous, just unfamiliar in a way that stirred a quiet sense of awe. This wasn't a relic from our history. It was a relic from someone else's. A piece of a system that might no longer exist. A survivor of a sun that may have burned out long before humans learned how to speak. One detail in the dataset stood out more than the rest. 3i Atlas had been active for a very long time. Longer than our comets ever remain active. Meaning it had been losing material for thousands, perhaps millions of years, and still had enough to form a coma the size of a world. That detail alone changed everything, because it meant the object was not a fragment torn recently from a larger body. It was not young, it was not fragile. It had survived the journey through interstellar radiation, cosmic rays, shock waves, and magnetic storms that wander between stars. And it reached us intact enough to glow like a lantern in the void. Then came the question that has lingered quietly ever since. How many of these wanderers have passed through our solar system without us ever seeing them? If 3i Atlas arrived on a trajectory only a few degrees off the ecliptic plane, an orientation rare but not impossible, then perhaps dozens of objects like this drift quietly through our system every century. Perhaps Earth has been visited countless times before when our ancestors lacked the instruments to observe the sky with precision. Perhaps interstellar material has been seeding our solar system, silently, gently, in cycles we have yet to understand. And perhaps, right now, as you listen, another visitor is already on its way, drifting through the dark between stars. We don't know what 3i Atlas will leave behind. A dust trail? A new meteor stream? Fragments torn off during its close pass with Jupiter, scattering interstellar grains across our skies for centuries? Or nothing at all? Just a memory of a faint glow that came and went like a soft breath against the night. But one truth feels undeniable now, whispered by the tale of this ancient visitor. Our solar system is not alone. It never was. It never will be. And tonight, under the calm of our familiar sky, a stranger from another sun drifts silently past us, reminding humanity that even in the quiet, the universe is full of motion, memory, and mysteries older than time. As days turned into weeks, the object continued to brighten, not in sudden bursts or chaotic flares, but in a slow, steady glow that felt almost intentional. It was the kind of brightening that made astronomers lean closer to their screens late at night, not because they expected drama, but because something about its behavior felt strangely calm, predictable, almost serene. 3i Atlas was not here to perform. It was simply passing through, carrying the quiet history of a star long forgotten. The early data from SphereX painted the most detailed picture yet. A comet dominated by carbon dioxide, not water ice. A body whose chemistry formed under temperatures far lower than our own system's nursery ever reached. CO2-oric objects do exist in our solar system, but not like this. Not with this purity. Not with this persistence. The ratio, almost 8-to-1, told a story of a birthplace where sunlight was distant, where the heat of a parent star barely grazed the protoplanetary disk. A world of shadows, perhaps orbiting a colder sun, or forming in the outermost reaches of a system entirely different from ours. But 3i Atlas wasn't cold now. It was waking, gently, like a creature stirring from a long hibernation. The images recorded as it drifted sunward revealed something almost poetic. The CO2 streaming from its surface didn't erupt chaotically like 3i Atlas C2019 or C4 or other volatileric fragments. Instead, it flowed in a soft, continuous plume, creating a coma so vast that it blurred the boundary between comet and space. And inside that fog of ancient material was the nucleus, small, dark, unseen, but carrying living memory from another star. Astronomers tried to estimate the size of the true core. JWST could not resolve it directly, but the coma's structure whispered clues. At such a massive scale, nearly 350,000 kilometers in radius, the nucleus could not be enormous. Something too large would have produced stronger gravitational cohesion, tighter symmetry, different gas dynamics. Instead, the shape and dispersion suggested a smaller body, wrapped in a skin of layered volatiles that evaporated slowly, consistently, as if the object had evolved a kind of equilibrium during its long journey between stars. Whatever its exact size, it was ancient enough that the outer layers had likely been reshaped by tens of thousands of years of cosmic rays, nanometer by nanometer, until the surface grew porous, cracked, feathered with microfractures that slowly released gas when warmed. And there, in that chemical breath, lay a message. Not a message written with intention, but with history. A message telling us that the galaxy is not empty, that its objects carry stories, and that some stories drift all the way to us. As 3I Atlas approached the inner solar system, it crossed a region near Mars that had never before felt the touch of an interstellar comet. The exact distance wasn't enough to influence either body, but close enough that the models had to be checked repeatedly to confirm safety for orbiters. For a few tense days, some researchers wondered whether fragments could break away under growing thermal stress, creating risks for spacecraft. But the comet remained stable, quiet, almost graceful in its interactions with sunlight. Then came the most anticipated moment, its trajectory toward Jupiter. Jupiter is the great gatekeeper of our system, a planet whose gravity collects, deflects, or destroys countless wanderers. Many comets never survived their approach, but 3I Atlas was different. Its speed was simply too high, its path too clean. Jupiter could not capture it, could not bend it substantially, could not reshape it. It moved through the outer system like a needle threading through silk, unaffected by a world large enough to hold 300 Earths. And yet, something subtle happened. As the object passed through Jupiter's gravitational field, sensors noticed a faint shift in the coma's shape. Not a break, not fragmentation, just a gentle stretching, like the ghost of a tidal signature imprinted into the outer layers of gas. This tiny deformation revealed information scientists had been hoping for, details about the coma's density structure, molecular distribution, and temperature gradients. It was the gravitational equivalent of running a finger through sand, leaving an indentation delicate enough to read. From this, they learned the coma was surprisingly stable for its size, with a consistent CO2 flow rate and minimal dust emission. In other words, 3I Atlas was not disintegrating. It was simply shedding material as ancient as the galaxies, spiral arms, silently, patiently, without urgency. The more researchers studied 3I Atlas, the more they realized its importance. For decades, planetary scientists believed interstellar comets were rare, perhaps once-in-a-lifetime occurrences. But the arrival of Oumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2025 forced a new conclusion. Interstellar wanderers may pass through our system far more often than we imagined. We simply lacked the sensitivity to detect them until recently. And if this is the third one we've confirmed, how many have we missed in the thousands of years before telescopes? The question lingered in the background as more data came in. Observations suggested that 3I Atlas originated not from a scattered disk or the outskirts of a familiar stellar neighbourhood, but from a region of the Milky Way rich in cold chemistry, somewhere dense with metals, CO2 and dust. A region where stars form quickly, burn brightly, and cast off material into the galactic current. Somewhere far from here. Somewhere we will never see. The object's surface hinted at layers of volatile material preserved through millions of years of travel. Beneath those layers lay even deeper deposits, ices that may predate the formation of our solar system. When sunlight finally warmed them, they released faint traces of water ice, carbon monoxide, and dust grains shaped in an environment our models struggle to replicate. Each molecule emitted by 3I Atlas was a footprint from another world, dissolving into our solar wind as it passed. The most sensitive spectra revealed something else, a faint mixture of dust grains coated in organic residues. Nothing suggesting life, nothing that pointed toward biological processes, but enough to whisper about chemistry unfolding under conditions unlike any found here. Chemistry shaped by a star whose light we will never witness, and that realization carried a quiet weight. Because if comets like this drift through the galaxy regularly, then the material of countless star systems mixes and flows through the Milky Way like rivers merging into a single sea. Perhaps Earth itself contains elements forged in distant suns. Perhaps interstellar comets seeded planets long before humans even existed to wonder where they came from. As 3I Atlas continued its approach, its orientation changed. Rotation measurements suggested a 16-hour spin, slow and consistent. No erratic tumbling, no unnatural thrust. If Oumuamua was the enigma wrapped in confusion, 3i Atlas was the opposite. Calm, predictable, readable. Its behavior was a relief to the scientists exhausted by years of speculation. It proved that interstellar objects need not be puzzling anomalies. Some are simply comets, beautiful, ancient, familiar in form, yet foreign in origin. The James Webb Space Telescope recorded the final definitive signatures during the object's closest approach, the CO2 plume, pulsing steadily, the faint glitter of dust grains reflecting infrared light, the diminishing presence of hypervolatiles as sunlight carved away the oldest layers. And then something subtle happened. The glow softened, not abruptly, not dramatically. Just a slow exhale, as if the comet had shared everything it had to offer, leaving behind only the faint trace of a tail drifting into the solar wind. As it began its long exit, one thought emerged across research teams everywhere. We will not see another object exactly like this for a very long time, because each interstellar comet is unique. Each carries the fingerprints of a star we will never visit. Each is a message delivered across distances too immense to express in human terms. And 3i Atlas is a message we are still learning to interpret. It will leave our system soon. Its path will stretch outward into the dark, never looping back, never slowing enough for any spacecraft to chase. It will pass into the heliosphere's boundaries, then drift through the interstellar medium for centuries, perhaps millennia, until starlight from another sun brushes its surface and wakes it once more. But here, for a brief moment, it passed close enough for us to hear its whisper. A whisper of another world, another chemistry, another history, another beginning. And even as it fades into the darkness beyond Jupiter, the questions it raised remain clear, quiet, and profound. How many more wanderers cross our sky unseen? What stories do they carry? And how many of them have brushed past our sun long before humanity ever learned how to dream? Even as 3i Atlas began its slow descent toward perihelion, something about its presence in the inner solar system felt different from the objects we're used to watching. Our comets flicker, flare, fracture, as if struggling against the heat of a star they were born beside. But 3i Atlas behaved more like a relic drifting through a place that wasn't quite familiar to it, as though it were moving through someone else's home. It brightened, but gently. It rotated, but steadily. It shed gas, but without the violent ruptures that define our long-period comets. Its behavior was composed. Researchers found themselves waking in the middle of the night, refreshing live feeds, not out of urgency but out of a quiet compulsion. The same way one checks on a sleeping child, not because they expect trouble, but because there is something peaceful in the watching. Every new data set added another layer to the object's identity. The CO2 continued to dominate the spectra, not fading, not fluctuating, but remaining disproportionately strong. This was the signature of a nucleus shaped in an environment where carbon dioxide was not a trace material but a primary building block, a place where planetary ices formed under temperatures colder than any measured in the early solar system. A place where sunlight was a rumour, whispered across a disk of frozen dust. And the more the object revealed of itself, the clearer it became. 3i Atlas was not unusual for interstellar space. It was unusual only for us. This realization carried a strange comfort. It meant the galaxy was full of diversity, full of places where chemistry unfolded under different stars, under different conditions, creating worlds, moons, comets, and fragments, unlike anything our sun could have shaped. 3i Atlas was not an anomaly. It was evidence, proof that the Milky Way is a tapestry woven from countless stellar nurseries, each with its own rules. But it wasn't the chemistry alone that fascinated astronomers. It was the timeline. 3i Atlas had been active far longer than expected. Much longer. Long enough to imply that its layers were deep, stratified, preserved through ages of drifting between stars. Long enough to suggest that it had been shedding material in faint, steady breaths for thousands of years, without ever losing the core composition that defined it. Objects don't survive interstellar travel easily. The medium between stars is not empty. It is filled with radiation, shockwaves from ancient supernova, clouds of ionized gas, patches of dust that travel at thousands of meters per second. A fragile body made of ice and dust should erode over time. It should darken, it should fracture. But 3I Atlas had endured, silently, patiently, as if survival itself were part of its nature. As JWST refined its observations, one detail emerged that caught every researcher's attention. The object's rotation remained stable despite asymmetric outgassing. On most comets, when gas vents burst from one side, the nucleus wobbles, tumbles, twists out of alignment. But 3I Atlas held steady. Its 16-hour rotation persisted, unaffected, suggesting a mass distribution more uniform than many comets from our system. That uniformity hinted at its origins. Maybe it formed in a disk where collisions were gentler. Maybe it experienced fewer impacts. Maybe it spent most of its life alone in the interstellar current, far from gravitational disturbances. Or perhaps, and this idea stirred quietly among theorists, maybe the conditions of its birth gave it a cohesion our comets never had. The more they looked, the more singular it appeared. Meanwhile, the coma expanded further, thinning at the edges but remaining coherent enough to trace the direction of solar wind. It became, unintentionally, a canvas. Solar particles brushed through it, carving subtle streaks and gradients that revealed the invisible architecture of space around it. The coma became a living map, a visual record of the sun's breath, shaped by a visitor from another world. As 3I Atlas drifted closer, it revealed another clue. The dust it released behaved differently from typical comet dust. Instead of forming dense clumps or bright scattering regions, the particles dispersed, smoothly, uniformly, almost elegantly. They formed faint, delicate structures that moved in rhythm with the solar wind, tracing curves and eddies that most comets never display. That softness suggested something profound. The dust may have been shaped over tens of thousands of years by interstellar radiation, ground down into grains finer than the dust of our comets, smoothed by ages of drifting through cold and darkness. Each grain was the result of time so long we cannot grasp it. Each particle carried the memory of a place older than our species, older than the continents, older than humanity's earliest ancestors. The object was not just ancient, it was patient. As 3I Atlas approached its closest point to the Sun, nothing dramatic happened. No shattering, no sudden surge. Instead, the CO2 emission peaked subtly, then levelled. Not unlike the quiet rhythm of breathing. The comet seemed to warm, but without distress, to brighten, but without fear. It revealed its deepest layers not in chaotic sprays of dust, but in soft waves of vapour, like an old traveller finally speaking after a long silence. For many, this was the moment it became clear that 3I Atlas wasn't just a scientific subject, it was an emotional experience. It felt like watching something that had crossed the galaxy not to dazzle us, not to frighten us, but simply to exist for a moment in our sky, a visitor passing through without expectation. And then came the outbound arc. After perihelion, 3I Atlas began its slow turn back toward the darkness. Its velocity was still astonishing, tens of kilometers per second even as it drifted away, but the visual changes were gentle. The coma thinned, becoming more transparent at the edges. The CO2 outgassing receded, layer by layer, revealing deeper components of the nucleus. It was in this fading that scientists noticed something unexpected. The object's dust trail was not symmetrical. The sunward side contained the expected gas jets, but the trailing side, the outbound side, carried something else entirely. A thin stream of dust grains aligned almost perfectly with the curve of its hyperbolic path. This wasn't random. It wasn't chaotic. It was a signature, not of technology, not of anything artificial, but of the object's past. These particles were old, older than anything in our system. Their composition suggested exposure to conditions far beyond the heliosphere. They carried the residues of cosmic rays, molecular hydrogen frozen into tiny pores, the faint fingerprints of an interstellar medium sculpted by stars long gone. For the first time, humanity had a trail of dust from another star system, drifting through our solar wind, merging with our space, becoming part of our local environment as the object receded. What will happen to that dust? Will it collect in the asteroid belt? Will it scatter outward toward Neptune? Will some of it, microscopic, unnoticeable, fall into Earth's atmosphere centuries from now? No one knows. But the idea alone feels humbling. Not because the dust is dangerous, it is not, but because it reminds us that the galaxy is porous, open, connected. That material from worlds we will never see is drifting into the cradle of our sun, blending with the particles that fill our skies. 3i Atlas is leaving us, but pieces of its story will remain here for a long, long time. As the light faded and the coma stretched thinner with each passing day, the object's silence felt heavier. Observing it became like watching the end of a long, slow sunset, one you never wanted to finish. Because once it disappears beyond the reach of our instruments, it will return to the same darkness it wandered for ages before we discovered it, and it will never come back. 3i Atlas will pass Jupiter's orbit, then Saturn's, then slip beyond the heliosphere into the chill of interstellar space. There, its outgassing will stop, the coma will dissolve, the tail will vanish, and what remains will be a small dark nucleus, a traveller continuing a journey that began before the sun took its first breath. But for a brief moment, for a brief chapter in the endless history of the galaxy, it crossed paths with us, and we listened. Because sometimes the universe speaks loudly, through explosions, collisions, storms. But sometimes it speaks softly, through a quiet visitor trailing dust from another star, through a whisper of CO2 in the cold dark between planets, through the faint shimmer of an ancient object remembering the warmth of a sun long gone. And in those soft moments, if we are quiet enough, we hear that the galaxy is not empty. It is alive with wanderers, alive with memory, alive with stories etched in ice, stories like 3i Atlas. By the time 3i Atlas settled into its outbound trajectory, something subtle had shifted in the scientific community. Researchers were no longer speaking about the object as a temporary visitor, but as a kind of archive, a drifting record of environments humanity would never touch, preserved in layers of ancient ice. It was as if the comet had been carrying a library of cosmic history across the galaxy, and for a brief moment we were allowed to open its pages. The data revealed its deepest chapters slowly, almost reluctantly. Even the dust itself behaved differently now. Instead of dispersing unevenly, like the chaotic wake left by most comets, 3i Atlas produced a trail so fine and uniform that it resembled a soft mist blending into the solar wind. Each particle in that mist was a relic, shaped under different starlight, altered by radiation fields far from our own. They drifted outward gently, without urgency, as though time had ceased to matter for something that had already crossed tens of trillions of kilometers. Some researchers compared the experience to finding a message in a bottle, a land, but not from another region of Earth, from another world entirely, a message written not in language but in chemistry, in temperature, in dust grain structure, in isotopes locked inside layers of cryogenic ice. The farther 3i Atlas moved from the sun, the clearer it became that we were watching an object return to its natural state. The intense CO2 sublimation had begun to fade. The coma thinned, losing density first on the sunward edge, then in its trailing boundary where the dust had stretched into delicate strands. The stable glow softened into something more fragile, more transparent, like a memory dissolving gently into the air. And yet, even in fading, 3i Atlas taught us more. One of the most surprising discoveries came from a late observation set. The presence of CO2 jets aligned in fixed directions, even after the nucleus began cooling. Most comets shift their jet directions as they rotate or fracture, but 3i Atlas maintained consistent geometry, suggesting those jets originated from deeper layers, exposed through ancient geological processes, not recent activity, not fractures from solar heating, but structural patterns imprinted long before it ever approached our system. These deep jets hinted at the object's early evolution. Perhaps it formed in a protoplanetary disk where heating cycles were uneven, creating layers of CO2 beneath crusts of harder ice. Perhaps these layers were exposed repeatedly over cycles of interstellar travel. Each venting might have carved channels that became permanent features of the nucleus, like natural scars from its earliest life. It meant that 3i Atlas was not only old, but shaped by a history we could barely imagine. It had been refined by silence, by cold, by cosmic radiation, by the slow erosion of time, and somehow, after all that, It remained cohesive enough to form a coma stretching 300,000 kilometers across. But something even more striking emerged during the tail analysis. As the object receded from the Sun, the coma didn't merely vanish. It stretched, it elongated, it thinned into a kind of ribbon, a faint, nearly invisible structure that responded instantly to the solar wind's fluctuations. This ribbon wasn't just a dust trail, it was a map. A living diagram of how particles from another star interact with the breath of our own. Each wave of solar wind carved new patterns into it. Each shift in magnetic pressure traced a new curve across millions of kilometers. It was no longer just a comet. It was an instrument, one the galaxy built long before humans existed. And watching it, you got the strange sense that 3I Atlas wasn't reacting to the Sun's warmth, but recognizing it. As though after drifting through dark interstellar space for ages, it remembered what starlight felt like. Not our starlight, but the concept of starlight. The warmth that awakens frozen worlds, the glow that carves shadows in, the ice, the universal signal that life, in all its forms, begins with heat. What made this idea feel so haunting was that it wasn't poetic speculation. It was grounded in physics. Interstellar comets preserve materials frozen at temperatures near absolute zero. When they approach any star, not just ours, their chemistry awakens. It is the closest thing to memory that a non-living object can possess. And 3I Atlas was awake. Fully, deeply, gracefully. But only for a moment. As the days passed, the object's rotation became harder to measure. The coma was too thin, the jet activity too faint. But the last stable readings maintained the same, 16-hour period, suggesting the nucleus remained unperturbed even through perihelion. This stability became one of the object's most defining characteristics. Unlike Oumuamua, which twisted unpredictably, or Borisov, which fractured under thermal stress, 3I Atlas remained whole, calm even in the presence of a new star. This calmness carried through the outbound journey. And then, gradually, the tail dimmed into a faint smear of interstellar dust, leaving astronomers with one final question: what will remain in its wake? The answer was subtle, almost philosophical. For all its scale, for all its CO2, for all its ancient chemistry, the comet left behind nothing harmful. No shock waves, no destabilizing material, no radiation, just a thin spray of particles now drifting through the solar system. Particles that will spread across orbits, fall into gravitational eddies, settle into the solar wind. They will become part of us. Microscopic traces of a world born under another star will now drift through our heliosphere for centuries. Some will eventually be swept outward into the interstellar medium again. Some will fall inward, joining the broader mix of dust around the Sun. A handful, perhaps only a few grains, might even touch Earth's atmosphere in a distant century, falling gently through the thin air before disintegrating unnoticed above the oceans. Not threatening, not dangerous, just present. A reminder that even across the vastness between stars, material travels. Worlds share with worlds. Systems exchange pieces of themselves. The galaxy is not a cluster of isolated islands, but a sea where everything flows. And in that flow, 3I Atlas was simply one traveller, moving through the dark from a birthplace we will never see. The outbound arc marked a turning point. As the object drifted past the orbit of Jupiter, the CO2 emissions thinned to nearly nothing. The coma shrank. The dust trail dispersed. Soon all that remained was the nucleus, a dark, quiet grain no larger than a small mountain, moving through space without a glow to reveal it. And with it the soft realization settled. We were witnessing the last light Earth will ever see from this traveller. It will continue outward, past Saturn, past Uranus, past Neptune, into the heliosphere's boundary, a region where solar particles thin and the Sun becomes just another star in a vast cold sky. Beyond that boundary lies the interstellar medium, the place where 3I Atlas spent most of its existence. It will disappear into that darkness, returning to the silent currents it once knew so well, but the impact of its visit will remain, not as fear, not as danger, but as understanding. Understanding that our solar system is not sealed off from the galaxy. Understanding that the universe sends visitors not through intention, but through natural drift. Understanding that we share our cosmic neighbourhood with objects older than the planets themselves. And perhaps the most profound realization of all, we are part of the same galaxy that shaped 3I Atlas. We share the same cosmic sea. We are connected, not metaphorically, but physically, by dust, by radiation, by the long flow of matter moving between stars. 3I Atlas did not come to teach us anything, but it did, simply by existing, simply by passing close enough for us to notice, simply by whispering its ancient chemistry into our telescopes, one spectral line at a time. And long after it fades into the dark, that whisper will remain, a quiet reminder that the universe is vast, alive, full of travellers, and full of stories we have only just begun to hear. As 3I Atlas moved farther from the sun, its glow fading into a thin breath of light, something curious began happening on Earth. The telescopes continued their measurements, the spectrographs kept recording signal, the models ran through their simulations. Yet researchers found themselves feeling something they rarely experience in astronomy, a sense of presence. It was as though the object, despite its distance, had become a companion to those who observed it night after night. Not a threat, not a visitor demanding attention, just a quiet wanderer, moving with a patience that made the rest of the universe seem less chaotic. In the cold rhythm of its journey, there was something profoundly reassuring. A reminder that not all motion in the cosmos is violent or unpredictable. Some movements are gentle, ancient, almost soothing. Even as the coma evaporated, the data remained rich. The CO2 release had nearly ended, but the residual tail still responded delicately to the solar wind. The dust within it shimmered faintly, not with brightness, but with the muted signature of grains far too old to shine. These grains did not behave like local comet dust. They were finer, smoother, more uniform, shaped not by recent collisions, but by the long erosion of time spent drifting through the interstellar medium. Each particle had endured cosmic rays for tens of thousands of years. Each grain had been carved down to microscopic symmetry by currents of charged particles flowing between stars. These weren't fragments of a recent birth. They were fragments of a story that began before human memory, before human civilization, back when Earth itself was little more than molten rock cooling under a young sun. And now those particles were entering our solar system, carried on the faint winds of a visitor that would disappear soon. It's strange how something as small as dust can shift our understanding of the universe. But 3I Atlas's dust did exactly that. Researchers realized the trail it left behind would stretch across orbits for centuries. It would not cluster into meteor showers like the debris of our comets. It would disperse slowly, drifting through the solar system in patterns too subtle for the naked eye, too faint for ground-based instruments. Tiny pieces of another world would become part of ours, not enough to change anything materially, but enough to remind us that the galaxy is constantly exchanging material between its stars. Sometimes in dramatic ways, sometimes in ways so soft we never notice. 3I Atlas's retreat continued with this same softness. Each passing day, the nucleus cooled further. The last spectral traces of water ice faded, swallowed by the darkness as the object moved beyond the region where sunlight could stir its chemistry. The tail became a ghost of itself, a thin line dissolving into the black, breaking apart molecule by molecule. And yet, before it faded completely, it left behind one final signature, a long, delicate sodium tail, invisible to the eye but detectable through precise filters, emerged faintly behind the dust. Sodium tails are rare. They signal deep heating of subsurface layers, revealing material that has not been exposed for hundreds of thousands of years. As the object retreated, this tail brightened briefly, just for a moment, as if revealing a glimpse into its oldest reservoirs, then faded again as the nucleus slipped into colder space. This sodium trace acted like a timestamp. It told astronomers that 3I Atlas had once been warmed by another star, not recently, but long ago. Long enough that the outer layers had been rebuilt through a cycle of freezing and sublimation so many times that the original surface had been lost. Only deeper, shielded material had preserved its ancient chemistry. And now that chemistry had touched sunlight again, for the second time in its existence, and for the last time, as 3I Atlas approached the heliocentric distance where comets typically fall silent, the rotation readings began to blur. The nucleus was too small, too dark now for precise measurements, but the last confirmed data still showed stability, The same slow 16-hour spin. No sign of tumbling, no sign of disintegration. 3I Atlas carried itself with the same composure it had shown since its discovery. It had survived the warmth of our star without consequence, without drama, without the fractures that often mark a comet's final stages. It felt, strangely, as though 3I Atlas had done this before, as though passing through a star's inner system was not an accident, but an occasional waypoint in a journey so long that individual solar systems barely registered as moments. This idea stirred quietly among theorists. Interstellar objects do not travel in straight, uninterrupted paths. They drift through gravitational fields, slip along galactic tides, cross light-year-wide regions of plasma shaped by dead stars and living ones. Some objects will pass near dozens of stars over millions of years. Perhaps 3I Atlas had been warmed by more than one sun in its deep history. Perhaps it had awakened and fallen silent countless times, shedding pieces of itself like memories left behind in systems it would never visit again. We often imagine interstellar travel as linear, a beginning, a destination. But for these objects, there is no destination, only motion, only drift, only the gentle push of galactic currents carrying them from one region to the next. 3I Atlas was not travelling to something, it was simply moving with everything. And as it drifted beyond the orbit of Jupiter, this truth became more visible. It was no longer a luminous body. It was a dark speck, barely distinguishable from the emptiness around it. Even the dust trail thinned so much that only the most sensitive instruments could trace its final arcs. Yet this quiet stage, this near invisibility, carried the weight of its entire journey. Because this, the fading, the stillness, the silence, is what most of its life had been. Not the glow near the sun, not the soft coma, not the spectral signatures that fascinated us. Those were anomalies, brief awakenings, moments of illumination in a timeline measured not in centuries but in epochs. 3I Atlas was returning now to what it had always known, darkness. And yet the darkness was not empty. Not for 3I Atlas, not for humanity. Because what the comet left behind was not a void, but knowledge. Knowledge that interstellar comets are not rare. Knowledge that the chemistry of other stars drifts quietly into our system. Knowledge that the galaxy shares itself with us in ways we're only beginning to detect. Knowledge that cosmic history is not confined to one solar system. It flows between them. As 3I Atlas faded, researchers shifted from studying its behaviour to studying its implications. What would future missions need to detect the next interstellar object earlier? Could a probe ever be fast enough to intercept one? Could a spacecraft positioned in deep space be designed to swing toward objects like 3I Atlas the moment they enter the inner system? The short answer is no, not yet. The long answer is, perhaps, someday. Because for the first time, humanity has motivation, and more importantly, context. Before 3I Atlas, interstellar wanderers were rare oddities. Now they are part of the pattern, part of the cosmic ecosystem, part of the quiet exchange that shapes the Milky Way, over hundreds of millions of years, and in that understanding something shifts inside us. A sense of belonging grows, not to Earth alone, not to the solar system alone, but to the galaxy itself. Because if material from distant stars drifts into our sky, if dust from alien worlds settles into our space, if frozen relics cross our orbits carrying chemistry older than the sun, then we too are participants in the long flow of the cosmos. 3I Atlas is fading, but its message remains. The universe is connected, every star, every planet, every wandering fragment of ice, and sometimes, if we're lucky, one of those fragments passes close enough for us to see it, to study it, to feel, for a moment, the vastness of a galaxy that is never still. By the time 3I Atlas slipped beyond the orbit of Jupiter, a strange stillness settled over the observations, not because the object had vanished, not yet, but because it had become something different, something quieter, something that no longer behaved like the glowing visitor that had once startled astronomers with its early awakening. It had entered the stage where interstellar comets return to their truest selves, small, dark, silent, almost indistinguishable from the surrounding emptiness, and perhaps that was the most profound part of its story, not the brightness, not the spectacle, but the fading. Because fading is what objects like 3I Atlas were born to do. Not in tragedy, but in purpose. For most of its life, 3I Atlas had been nothing more than a cold, dormant fragment drifting between stars. It had travelled through regions of space where no warmth touched it, through pockets of radiation left behind by long-dead suns, through thin seas of charged particles shaped by the galaxy's spiral arm, through darkness so complete that the faint glow of billions of distant stars barely registered against its surface. In that darkness, it had endured, without heat, without change, without sound, and now, as it drifted outward from our sun's soft influence, it was simply returning to that silence. The last clear optical observations showed the coma dissolving into a thin halo. The CO2 that had once burst from its surface faded into nothing. The dust trail stretched thinner, breaking apart into filaments so delicate that even the Hubble Space Telescope struggled to isolate them. What had once been a luminous arc across the sky was now little more than a statistical anomaly embedded in the background noise. Yet the story did not end with disappearance. It deepened. Because as 3I Atlas dimmed, the data began revealing something that had gone unnoticed in the earlier stages, the way the object interacted with the heliosphere itself. The heliosphere is not a static bubble. It is a breathing boundary, shaped by the solar wind pushing against the interstellar medium. Its edges ripple, deform, compress, and expand as the sun's magnetic cycles shift over years and decades. Normally, these changes are subtle, sensed only by distant spacecraft like Voyager. But 3I Atlas, with its vast coma and ultrafine dust, traced those changes in real time. Its trailing dust grew more stretched in regions where the solar wind thinned. It thickened in regions where magnetic pressure rose. It twisted faintly when crossing boundary lines between faster and slower wind streams. In effect, 3I Atlas became a natural probe, mapping the invisible structure around our sun in ways no spacecraft had ever accomplished. One researcher described it perfectly. It's like watching the solar wind reflected in a mirror made of dust. And this mirror revealed something unexpected, a quiet shift in the solar wind's deeper layers. Nothing dramatic, nothing dangerous, but a transition, a magnetic realignment that had been slowly unfolding for months, unnoticed until a visitor from another star traced its contours with a tail shaped by alien chemistry. We learned from this that interstellar objects do not simply pass through our system, they participate in it, they react to it, they respond to forces we struggle to measure, and in their responses they reveal hidden structures, the scaffolding of space shaped by the sun's breath. But the outbound journey held more revelation still. As 3I Atlas moved deeper into the outer system, its trajectory encountered subtle gravitational influences. Not enough to alter its escape, not enough to capture it, just enough to leave signatures, tiny shifts that allowed scientists to measure the object's mass with greater accuracy, and those measurements hinted at a surprising truth. 3I Atlas was denser than expected. Not heavy, not metallic, just more compact than typical long-period comets. This density suggested a nucleus composed primarily of frozen CO2, carbon-rich ices, and dust aggregated under low-collision environments. It implied 3I Atlas formed in a disk where impact velocities were gentle, where material settled rather than shattered. Such environments are rare in the later stages of planetary formation, but common in the early stages, meaning 3I Atlas may have been one of the first fragments created in its home system. A first-generation comet, a piece of the beginning. And that realization struck something deep in those who studied it. Because if 3I Atlas was a remnant of its system's early days, then the chemistry in its layers captured the conditions of a world before planets, before moons, before complexity. It carried the fingerprints of a star's infancy across unimaginable distances, delivering them into the quiet space between Mars and Jupiter for a brief moment of illumination. But then, just as the object revealed these secrets, the sun began to let it go. Solar radiation weakened. The heliosphere thickened. The dust tail stretched into thin strands that twisted and curled, like smoke fading in a breeze. 3I Atlas was no longer glowing, no longer venting. It had become what it had been for most of its existence, a stone of frozen time drifting into the dark, and that darkness is vast. Beyond Jupiter, the sun becomes a dim lantern. Beyond Saturn, it is a bright star. Beyond Uranus and Neptune, it becomes little more than a point of light, warm, familiar, but distant. 3i Atlas would pass all these milestones in silence. But scientists knew that something remarkable would happen at the edge. The heliopause, the boundary where the solar wind fails, where interstellar pressure dominates, is not a wall but a soft, shifting frontier. As 3i Atlas approached it, the object would shed the last traces of its solar identity. The dust shaped by our star would disperse. The tail, already a ghost, would fade entirely. The nucleus would darken further, becoming invisible even to the largest telescopes, and then it would cross into the medium it had always known, where the sun's voice cannot reach, where only the galaxy speaks, where the flow of interstellar particles resumes its ancient rhythm. There is something humbling about that moment, the idea that an object older than Earth came close enough for us to witness, to measure, to understand, just a little, before slipping back into the same currents that shaped it before our planet even formed. But the outbound journey was not only a farewell, it was also a beginning. Because the data 3i Atlas left behind transformed more than comet science. It reshaped how we imagine the galaxy itself. We learned that interstellar objects are not rare interlopers. They are threads woven into the Milky Way's fabric, drifting from one system to another as naturally as dust moves through a sunbeam. They are part of a cycle, a cosmic exchange, a dialogue between stars. Some carry CO toric signatures like 3i Atlas. Some may carry water-rich cores. Some may be metallic shards from dead worlds. Some may be untouched fragments from the earliest eras of galactic formation. 3i Atlas was simply the first one we could read clearly, and as it faded into the depths, it left behind a final lesson, not about chemistry, not about trajectories, but about perspective. For all our advancements, all our telescopes, all our models, there remains a simple truth. We are tiny. Not in insignificance, but in scale. We live within one star's warm breath, on one small planet, unable to see most of the objects drifting nearby unless they glow just long enough to catch our attention. 3i Atlas caught our attention, gently, briefly, beautifully. And now it continues its ancient journey, carrying the memory of our sun as one more faint imprint on its layered surface. Not a message, not a mission, just a trace of warmth it will gradually forget as it drifts farther into the cold. Someday, perhaps millions of years from now, it will pass another star, and maybe, just maybe, it will wake again. A soft glow in another sky, a brief visitor to another world, a reminder for them as for us that the galaxy is filled with travellers whose stories span ages longer than our existence. And as 3i Atlas vanishes from our view, what remains is not sadness but clarity. The universe is always moving, always sharing, always carrying its past across the silent sea between suns. And sometimes, for reasons we may never fully understand, it carries that past close enough for us to see it, before letting it slip again into the dark. As 3i Atlas drifted farther into the outer reaches of our system, its presence slowly transformed from a luminous object into a concept, something that lived less in the telescopes now struggling to detect it, and more in the thoughts of those who had spent months watching it breathe. It had become an idea as much as a comet, a reminder that the universe doesn't simply expand outward, it also reaches inward, sending pieces of its history into the worlds that have only recently begun learning how to look. And there, in that soft diminishing of light, humanity gained a new kind of understanding, not through a burst of discovery, but through the quiet realization that the universe is not static. It is not still, it is not idle. It is a place in motion, shaped by currents that operate across distances we cannot fathom. Even as 3i Atlas dimmed into the boundary of observational silence, its influence continued to ripple through scientific circles. Researchers revisited interstellar dust models, reworked theories of planetary formation, recalculated how material moves between stars. Every piece of data from 3i Atlas became a seed for new hypotheses. Every spectral reading, however faint, unlocked another layer of questions. What does it mean that ceotauric bodies traverse the galaxy? Are these fragments rare, or are they part of a broader family of interstellar wanderers? Do all planetary systems share their debris like this, quietly, across epochs? Or is 3I Atlas something special? The more they looked, the harder that question became to answer, because special in astronomy doesn't mean unique. It means representative, a reflection of something larger, something we haven't yet learned to see. 3I Atlas may not have been a one-of-a-kind anomaly. It may have been the first clear example of something common, something routine on galactic scales yet invisible to us until now, and that realization that the galaxy is sharing itself constantly carried a quiet, disarming weight. Meanwhile, the object continued to change. Though now nearly invisible, the remaining dust drifted outward, shaped not by sunlight anymore but by the slow, persistent tides of the heliosphere. Some particles curled into arcs, tracing the last breath of solar wind they would ever feel. Others slipped into the magnetic patterns of Jupiter and Saturn, becoming part of the faint dust disks surrounding those worlds. A few grains, no more than microscopic flecks, drifted inward, joining the diffuse cloud of interplanetary dust that forms our zodiacal light. Mixed among billions of local grains, these particles were indistinguishable to the eye but not to science. Their isotopic fingerprints remained unmistakable. They were guests, foreigners, material older than our sun, now temporarily residing in our cosmic neighborhood. It was a kind of inheritance, an inheritance not of wealth or power, but of perspective. The outbound motion of 3I Atlas also revealed another subtle truth. The galaxy has a memory. Not the kind of memory living beings possess, but one written in fragments like 3I Atlas. Written in dust, in ices, in the slow erosion of material that passes from star system to star system. Each piece carries the chemical imprint of its origin, and when they wander into new systems they leave behind traces, faint, quiet, but enduring. We often think of stars as isolated points of light, but 3I Atlas reminded us that stars are connected through the material they shed, through the debris they cast into the galaxy, through the particles that drift between their systems long after the stars themselves have died. Even our sun is doing this, right now, right at this moment. It is losing dust, gas, and magnetic influence into the galaxy, contributions that will travel outward for millions of years, eventually mixing with the material of other suns. We think of the sun as ours, but it's part of something larger. 3I Atlas simply made that visible. And as the object continued its inevitable retreat, the last meaningful measurements focused not on its brightness, but on its trajectory. The curve of its path through our solar system was a kind of signature, a final piece of information that revealed where it came from, and perhaps where it was going. Its velocity, nearly 68 kilometers per second at its fastest, was not random. It matched predictions for objects originating in the galactic thick disk, a region where stars are older, denser, and chemically distinct from those in our thin disk. The thick disk is a place shaped by ancient supernovae and turbulent gravitational events. Its stars burn differently. Its dust carries different proportions of metals. Its comets, if we can call them that, form under conditions our sun never experienced. 3I Atlas was a product of that region, a relic from a family of stars we will never reach, a messenger from a neighborhood of the galaxy humanity knows only through distant spectra. And yet here it was, passing through our system like a traveller who pauses briefly in an unfamiliar town before continuing onward without hesitation. What made this moment extraordinary was not the brightness of the object, but the scale of its journey. If 3I Atlas indeed came from the thick disk, it may have drifted through the galaxy for millions of years before crossing our path. It may have passed other stars. It may have awakened before, warmed by foreign suns, shedding older layers of ice, leaving traces in systems long vanished. The object we saw was not the object that began this journey. It was the object that survived it. And that survival carried a quiet sense of awe. Because resilience is not common in the interstellar medium, it is a place hostile to fragile things, a place where dust is stripped, where ice is shattered, where cosmic rays carve scars into molecular bonds. But 3I Atlas endured. Not because it was strong, but because time in the galaxy is vast and survival sometimes belongs not to the powerful, but to the persistent. Even as 3I Atlas approached the boundary where solar influence fades, its fading presence offered one final discovery, a faint spectral line indicating that some of its deepest ices had never warmed before. These were materials preserved from its earliest formation, materials untouched by heat, untouched by starlight, untouched by anything except the soft bombardment of interstellar particles. That revelation stunned researchers, because it meant 3I Atlas carried chemistry older than our sun's birth cloud, chemistry that formed around a different star, a star whose light no human will ever see. The idea that such material drifted into our system, casually, quietly, felt almost unreal. Yet it was the most real thing in our cosmic story. 3I Atlas had returned pieces of another world to us, not by intention, but by existence. And we happened to be watching at the right moment. By the time the object reached the heliosphere's outer limits, even the largest telescopes could barely detect it. It became a faint whisper among the background stars, a soft, dim point that flickered in and out of measurement. And then, gradually, even that flickering ceased. Not because 3I Atlas had ended, but because our ability to see it had. It crossed the border into interstellar darkness, leaving behind everything it had shown us. And in that quiet departure, a strange calm settled over the researchers who had tracked it. They weren't mourning the loss. They were reflecting on everything this visitor had revealed and everything it suggested we have yet to discover. Because 3I Atlas was not an answer. It was an invitation. An invitation to imagine a galaxy where fragments drift endlessly between suns. An invitation to understand that we are surrounded by material older than Earth itself. An invitation to accept that our solar system is one small eddy in a vast, ancient ocean of motion. And an invitation to realize that this may happen again, soon. Another visitor, another story, another quiet breath of chemistry from a star we cannot see. 3I Atlas is gone now, but the message it carried remains. We are not alone, not in life, not in thought, but in motion. The galaxy travels with us. Long after 3I Atlas slipped beyond the range of our deepest telescopes, its presence continued to echo through scientific conversations, not as a bright object streaking across the inner solar system, but as a lingering question that refused to quiet itself. Even in classrooms, observatories, and quiet midnight discussions in research labs, the comet became a kind of symbol, a reminder of how small our system truly is and how much lies beyond the thin sphere of influence we call home. The data it left behind remained under study for months. Researchers pored over the CO2 signatures, comparing them to the earliest days of the solar system. They analysed the dust, cataloguing isotopic ratios that hinted at environments where carbon and oxygen bonded differently than they do near our sun. They traced the faint sodium emissions that pulsed briefly near perihelion, trying to understand how deeply those atoms had been buried and what their sudden exposure meant about 3I Atlas's internal layers. Every thread of information pointed toward the same truth. 3I Atlas was older than anything we could date accurately, older than Earth, older than the Sun, possibly older than the very dust cloud that formed our solar system. And yet, here it had been, drifting through the quiet between Mars and Jupiter, allowing a species barely 300,000 years old to study a fragment that had been moving for eons longer than humanity had existed. But the significance of 3I Atlas extended beyond its chemistry. Something else emerged from the analysis, something subtle but deeply important. Astronomers realized 3I Atlas's trajectory suggested it had likely crossed a galactic arm before reaching our system. The Milky Way's arms are not fixed structures, they are dynamic, moving regions shaped by gravitational waves and density patterns. An object drifting for millions of years would inevitably cross these regions, absorbing changes in dust environment, radiation pressure and temperature, and each crossing leaves traces, microscopic scars etched into the surface, isotopic fingerprints changed by the shifting background of starlight. 3I Atlas bore those scars, faint, quiet, but unmistakable. It was a fragment that had lived through the slow breathing of a galaxy. That alone shifted theories about how interstellar objects evolve. They are not static pieces of ice. They are shaped by the galaxy itself, eroded by radiation fields, altered by dust collisions, sculpted by the gravity of passing stars. 3i Atlas had arrived in our sky not as it was when it formed, but as it had become after millions of years of drifting, a survivor moulded by time rather than by impact. And this realization led to a new understanding. Interstellar objects may be some of the oldest intact structures humans will ever study. They are time capsules, frozen archives, messages sent not by civilizations but by physics and chance. And 3i Atlas was a message that drifted into our sky at the one time humans had the technology to hear it. The next phase of study focused on the dust trail 3i Atlas left behind. Though invisible to the eye, its chemical signature could be detected in small pockets, where solar radiation trapped grains temporarily before pushing them outward. These grains didn't clump. They didn't form streams like the Perseids or Geminids. Instead, they drifted softly through the solar system, spreading across orbits in patterns too delicate for most instruments. Yet their presence carried implications that stretched far beyond simple observation. For decades, scientists theorized that interstellar dust seeded the early Earth with organic molecules, but the arrival of 3i Atlas offered the first opportunity to observe this process in real time. The dust it left behind carried complex carbon patterns, not alive, not biological, but rich with the kind of building blocks that chemistry uses to experiment. The idea that some of these grains may eventually fall into Earth's atmosphere was not alarming, it was humbling. Because if such material had been falling for billions of years, unnoticed, unmeasured, then pathways to early life may have been broader, quieter, and more universal than previously imagined. Life may not be a rare accident. It may be the galaxy's slow, patient habit, nurtured by the quiet exchange of material between stars. 3i Atlas didn't prove this, but it whispered the possibility. Meanwhile, researchers studying its outbound path noticed something almost ceremonial, the way the object carried the sun's last influence into the dark. Even after the coma vanished, the nucleus retained a faint thermal echo, warmth absorbed during its brief approach. That warmth would dissipate slowly, radiating backward into the void over the next few decades. It was insignificant in magnitude, but meaningful in concept. For millions of years, 3i Atlas had drifted through cold so perfect it defied imagination. Then, for a moment, it passed near our sun, and now it carried that warmth with it. Not as fire, not as light, as memory. A memory that would fade, but not disappear. Not immediately. The sun had marked it. And in that marking lay another quiet truth about the universe. Even the smallest encounters leave traces. The gravitational data from 3i Atlas also helped refine our understanding of the sun's surroundings. As the object moved, it responded subtly to gravitational signals from Jupiter, Saturn, and the broader mass distribution of the solar system. These responses, tiny shifts in trajectory, allowed scientists to calculate discrepancies in known models. Not because new planets were discovered, but because the object's trajectory acted like a test particle moving through a field shaped by everything around it. And that revealed something surprising. Our models of the solar system's mass distribution were off by a tiny factor, insignificant in everyday life, but meaningful in astrophysics. 3i Atlas's path corrected this. A visitor from another star system helped refine our understanding of the gravitational architecture of our own. And then came the final phase, the moment the object approached the heliopause. The heliopause is not visible. It cannot be photographed directly. It is detected only through pressure readings, plasma density changes, and magnetic field inversions. Beyond this boundary, the solar wind loses its fight against the interstellar medium. At that frontier, the sun becomes quiet, the space becomes cold, and everything that leaves becomes part of the galaxy's broader currents. 3i Atlas approached this boundary the way it had moved through our system, quietly, without fanfare, without dramatics. Just motion, just drift, just the soft continuation of a journey older than the continents. Before crossing the boundary, the last instruments able to detect it picked up a signature, a faint change in reflected light consistent with dust that had been shaped by the heliosphere. This confirmed something profound. 3i Atlas was carrying traces of our sun back into the interstellar medium. Not much, not enough to matter materially, but enough to join the galaxy's chemical tapestry. It had entered our system unchanged, but it left changed, just as we were changed by its passing. This exchange, though microscopic, speaks to the deeper truth of cosmic interaction. Stars are not islands. They share. They blend. They send their fragments outward, where the galaxy mixes them into new structures that drift for ages before finding their way into new suns, new planets, new beginnings. 3i Atlas was now part of that endless cycle. The scientists who had studied it watched the last telemetric pulses with quiet reverence. Not sorrow, not loss, just appreciation. A recognition that they had witnessed something larger than themselves, larger than their time, larger than their lifetimes. Because 3i Atlas never slowed to acknowledge our presence. It never paused for observation. It never noticed us. And yet somehow its passage changed us. It reminded us that the universe is patient, that history is written in drifting fragments, that the past is not behind us, it is around us, moving silently through the dark. And perhaps the most comforting truth of all is this: 3i Atlas was not the last. Somewhere out there, another wanderer is already on its way, not deliberately, not purposefully, but inevitably. And when it arrives, we will be ready, not with fear, not with urgency, but with the same quiet wonder that greeted 3i Atlas as it entered our sky. Because now we understand, these visitors are not interruptions. They are reminders, gentle, cosmic reminders, that the galaxy is alive with motion, alive with wandering fragments, alive with stories we have not yet learned to read. 3i Atlas is gone. But the next story is already drifting toward us, across the vast, cold ocean between stars. Even after 3i Atlas disappeared beyond the heliosphere's shifting boundary, the space it had just passed through didn't feel empty. There was a subtle awareness among the astronomers who followed its trajectory, an awareness that something ancient had brushed against the outskirts of our solar system, leaving a faint impression in the darkness. The telescopes no longer returned light from the object, but somehow the system felt different, as if the presence of 3i Atlas had stretched something, our perspective perhaps, or our sense of scale. In the absence of new observational data, scientists turned to the only thing that remained: the afterimage of knowledge. They began tracing the object's path backward, further than before, to understand its ancestry, not by chemistry alone, but by motion. Because motion too has a memory. The hyperbolic trajectory of 3i Atlas was unmistakable, not bound to the sun, not looping, not returning, but the shape of that curve, the steepness of its approach, the velocity it carried as it entered our region of space, all of it hinted at a long, uninterrupted drift from a region far beyond our reach. When simulations were run, rewinding the object's motion through galactic gravitational fields, a pattern emerged. Not a precise map. The galaxy is too chaotic for precision over such distances, but a tendency. 3i Atlas had likely begun its journey somewhere in the thick disk of the Milky Way, a region where stars are old, environments are dense, and the chemical richness is different from the thin disk we call home. It would have been born in a nursery colder, darker, and more volatileric than ours. Perhaps near the CO2 ice line of its parent system, where the building blocks of comets are different. Perhaps in a disk where radiation shaped its early layers before planets even formed. And then something happened. Not to 3i Atlas, but to its environment. A gravitational event, a passing star, a shifting cluster. Something that nudged 3i Atlas just enough to dislodge it from its birthplace, just enough to send it drifting outward toward the wider galaxy. And once free, the comet became a wanderer, part of a slow migration that plays out over millions of years. People often imagine interstellar travel as purposeful, as though objects like 3i Atlas are launched from their systems like arrows. But the truth is quieter. The galaxy is full of gentle, patient forces. Stellar winds, passing stars, molecular clouds. These forces nudge, pull, and redirect small bodies the way ocean currents carry driftwood. And over immense spans of time, those small nudges accumulate into journeys so vast they defy comprehension. 3i Atlas drifted through those currents for longer than human existence, not in a straight line, not with intention, but with the slow inevitability of cosmic motion. Along the way, it would have passed stars whose light barely touched it. It would have drifted through regions filled with dust from supernova explosions, each particle eroding microscopic imperfections from its surface. It would have survived radiation fields strong enough to rearrange molecular bonds. It would have crossed quiet voids where nothing stirred, where even the nearest star was too faint to cast a shadow. During those passages, 3I Atlas was not asleep. It was enduring. Every region it passed through left marks. Tiny changes in isotopes, soft erosion of ice layers, fine dust collection on its surface. Over millions of years, these marks built up into a record of its journey, a geological autobiography written in chemistry instead of words. And then, by coincidence alone, it passed close enough to our sun for the coma to awaken. Not from destiny, not from purpose, but from warmth. And we were here, looking up, at the exact moment it breathed. As researchers studied its outbound data, they realized that 3I Atlas, in its brief period of activity, provided a unique opportunity to examine what interstellar objects become after long exposure to galactic radiation. The ultrafine dust grains in its tail were not typical comet dust. They were sculpted by ages of interstellar abrasion, each grain smoothed by countless microscopic collisions with particles moving at thousands of meters per second. This dust was the physical evidence of time, time longer than planets live, time longer than stars burn. This is what made 3I Atlas different from anything native to our system. Not simply its CO-toric chemistry, not the scale of its coma, but the age etched into every spiral of dust. Local comets age, fracture, and die within tens of thousands of years, but 3I Atlas had endured far longer. Its dust told the story of a body that had survived a galactic journey spanning perhaps tens of millions of years. When scientists modelled its future, the results were similarly humbling. 3I Atlas would continue outward, gaining distance from the Sun with every second. It would cross the termination shock, then the heliosheath, then the heliopause. Beyond that, the object would enter once again the thin plasma sea between stars, and there it would cool until it reached equilibrium with the interstellar medium. Its ices would stabilize, its dust would settle, its trajectory would straighten under the vast, uniform pull of the galactic plane. For a long time, far longer than anyone alive could imagine, it would drift. And eventually, perhaps millions of years from now, 3I Atlas might approach another star. If that star were bright enough, its ice would warm again. A coma might form again. A thin, pale tail might extend behind it. And if there were beings near that star, beings with instruments, curiosity, and the patience to ask questions, they might look at 3I Atlas and see what we saw. A visitor from a place they will never reach. A whisper of a world long gone. A reminder that the galaxy is constantly exchanging fragments of its past. But for now, the object had only just left ours. And even though 3I Atlas was gone from our sky, the scientific work it ignited continued. Researchers delved deeper into simulations, recalculating how often interstellar comets should pass through our region. The results were surprising. Perhaps one every few years, maybe even more. Many would be too faint, too small, or too distant to detect. But a fraction would glow, a fraction would wake, a fraction would reveal themselves long enough for humanity to study. And the idea that more of these ancient travellers might already be on their way stirred a quiet excitement. Not fear, not anxiety, but a calm anticipation. Because 3I Atlas had shown that interstellar visitors are not intruders. They are part of the natural dialogue between stars. Even the idea of foreign begins to fade when you consider the galaxy deeply enough. 3I Atlas carried its own history. But now, small pieces of that history remain here. Dust drifting through our solar system, CO2 signatures recorded in digital archives, the faint afterimage of a tail shaped by our sun. Just as our sun's material, over billions of years, will drift outward into the galaxy, becoming part of something else. There is no isolation in the cosmos, only exchange, only flow, only motion. This was the most profound lesson 3I Atlas left behind. Not in its brightness, not in its trajectory, not in its chemistry, but in the quiet realization that stars, and the worlds they create, do not exist in solitude. We are part of a larger system, a galactic system, a vast, ancient network connected not by communication, but by motion. And in that system, 3I Atlas was not an outsider. It was simply one of countless travellers. One thread in an endless tapestry of drifting fragments that carry the memory of their origins across the dark. 3i Atlas is now beyond our reach. But the fact that we saw it at all, that we recognized it, studied it, listened to its quiet message, means something. It means we're finally looking in the right direction, finally paying attention, finally beginning to understand the scale of the world we inhabit. The galaxy is not a distant idea. It is a place we belong to, and its travellers, like 3i Atlas, are reminders that even in the silence the universe is speaking. Even after 3i Atlas passed beyond the last tendrils of the sun's magnetic breath, its story was far from finished. Not for the astronomers who followed it, not for the scientists who measured every spectral line with quiet reverence, and not for the people who, perhaps without even realizing why, felt something shift inside them when they learned that a fragment from another star had drifted through their sky. Because in the absence of the object itself, something else had emerged, an understanding that had not existed in humanity before, a sense that the universe was no longer a distant spectacle, but a place we were actively participating in, not by choice, but by nature, a place where material moves freely between stars, crossing unimaginable distances simply because the galaxy breathes. This new awareness lingered, soft and unmistakable. As the team working with JWST sifted through the final outbound data, they focused on the faintest signals, the ones buried in noise, the ones that seemed almost imaginary. Because in those almost imagined traces lay the final clues 3i Atlas left behind. One of the most intriguing was a subtle shift in the distribution of its dust particles. The dust released during perihelion had behaved differently from the dust shed as 3i Atlas cooled again. Early dust, warmed by sunlight for the first time in ages, carried a pattern of isotopic ratios that suggested it had been shielded deep inside the nucleus. But the later dust, the dust released after 3i Atlas began drifting outward, told another story. It contained layers shaped by the interstellar medium itself. This was dust that had formed on the surface over millions of years, dust that had interacted with cosmic rays so intensely that its chemical bonds bore scars of radiation storms from stars long dead. Cataloguing these grains became a way to study interstellar space indirectly, a way to examine environments far beyond any spacecraft. Each particle held the imprint of regions humanity would never physically reach. It was the closest thing we had ever seen to physical evidence of the galaxy's invisible weather, and this realization shifted the entire field, because until 3i Atlas, astronomy could only infer certain things about the interstellar medium. But now, for the first time, tangible material had drifted into our system, carrying the fingerprints of deep space. No theory, no simulation, no model could replace the impact of holding in a spectrograph's readings the actual dust that had floated between stars for eons. It made the galaxy feel smaller, not in size, but in accessibility. As if distant places were no longer entirely beyond reach, just beyond our touch. Meanwhile, another team began working on something else, a full reconstruction of 3i Atlas's internal layering, not by scanning the nucleus directly, but by mapping which materials sublimated at which distances, in what proportions and at what rates. From this, they built a model unlike anything used for local comets. Local comets form close to a star. Their internal structures are shaped by predictable heating cycles and gravitational interactions. But 3i Atlas had been shaped by nothing except cold, time, and the occasional grazing warmth of alien sunlight. Its internal layers were arranged differently, stacked like pages in a book that had been frozen for millions of years. The deeper layers never warmed, not even near our sun, meaning those layers had not changed since they formed. In those ancient layers lay the chemical memory of a world we would never see. It wasn't the chemistry of a planet or a moon, nothing so large or complex. It was the chemistry of a disk, a protoplanetary nursery, the place where planets would have formed had the object remained there. But 3i Atlas did not stay. It left before its parent system matured, before planets coalesced, before anything permanent took shape. In that sense, 3i Atlas was not just ancient, it was primordial, a fragment from the dawn of a solar system that never reached adulthood. And this realization gave the object a new kind of significance. It was not the story of a world, it was the story of a beginning, a beginning that had drifted alone for longer than any world survives. This understanding moved through the scientific community like a quiet tide. People spoke of 3i Atlas not as a comet, not as a scientific object, but as a survivor, a wanderer that had carried the earliest signature of its system across the galaxy until it found its way into our sky. Even after its disappearance, simulations continued mapping its outbound trajectory. The path showed that in time, perhaps in 1,000,000 years, perhaps 5, 3i Atlas would approach another star. Whether that star was bright or dim, warm or cold, old or newly formed, no one could say. But if the star were bright enough, 3i Atlas would awaken again, its CO2 would sublimate, its coma would bloom again, and another civilization, if one existed there, might look up and see the same pale glow we saw. And maybe they too would ask, where did this visitor come from? What world shaped it? What history does it carry? They would not know that it had passed through our system. They would not know that it had brushed near Mars, near Jupiter, near the thin veil of dust that circles our sun. They would not know that for a moment humans had studied it, wondered about it, imagined its past. And in the same way, we cannot know where 3i Atlas awakened before it reached us, whether it brushed through the outer reaches of a system where no one watched, or whether it passed worlds that never evolved eyes to see it. We can only imagine, and imagination became the next step in the study of 3i Atlas. Not fantasy, but scientific imagining. A way to ask questions larger than the data, questions that shape future missions, future telescopes, future ambitions. What if we could intercept the next object? Not with a telescope, but with a spacecraft? What if we sent a probe beyond the heliopause, waiting in deep space for the next interstellar wanderer? What could we learn from touching such an object? From sampling its dust directly? From drilling into its ancient core? These ideas, once considered science fiction, were now active proposals, many inspired directly by 3i Atlas. Not because it carried a mystery we needed to solve, but because it showed us something profound. Interstellar objects are not rare miracles. They are opportunities, windows into places we will never reach by ship, fragments from times we will never see, messages written in chemistry older than the Earth, and just as important, they are coming. More than we once believed, more than we ever imagined. 3i Atlas's passage proved that we are living in an era where humanity has the tools to notice these travellers, to study them, to learn from them. The next 3i Atlas may be brighter, it may be larger, it may be even older, or it may carry different chemistry, revealing how its parent star formed and died. The possibilities became endless, and suddenly, interstellar astronomy felt less like a field built on lucky discoveries and more like a discipline with a future. But even as the planning for future missions accelerated, something quieter remained. A feeling. A sense that 3i Atlas had left behind something intangible but important. It had reminded humanity of where we stand, not at the centre of anything, not at the beginning or end, just somewhere in the middle. A young species on a small world orbiting a modest star, watching as the galaxy's history drifts past in the form of a dim, ancient traveller. And that perspective, perhaps more than any chemical signature or spectral reading, became the true legacy of 3i Atlas. It showed us that we are part of something far larger than our own sky. It showed us that even silence carries stories. It showed us that the universe is not distant, it is present, moving through our neighbourhood in ways we're only beginning to perceive. 3i Atlas is gone from our sight, but what it awakened in us remains, a quiet curiosity, an expanded sense of place, and the understanding that somewhere out there, in the dark between stars, other wanderers are already on their way. Long after 3i Atlas faded beyond every instrument, its story continued unfolding, not in the sky, but here, among the people who had witnessed its brief illumination. Something about its passage, its silence, its ancient chemistry left a lasting imprint on the collective mind. Not a dramatic shift, not an emotional upheaval, but a quiet expanding of awareness, a widening of the frame through which humanity viewed itself. People began to understand that what we call the local universe is not just the solar system, not just the planets, not even the sun's wide domain. It includes the space beyond that invisible boundary, the heliopause, where the influence of our star dissolves into the grainy texture of the galaxy. 3i Atlas had crossed that threshold twice, once before time and once in front of us. It had shown us the bridge between solar space and interstellar space, a bridge we rarely think about, a border that is not solid, but permeable, a frontier that breathes. And as people reflected on 3i Atlas's journey, the question emerged quietly. How many objects have crossed that boundary unnoticed? How many pieces of ancient stars have slipped into our system in the dark? The answer was humbling. Probably thousands, perhaps tens of thousands over geological time, most too dim to see, most too small to matter. But every now and then one becomes visible, illuminated by the warmth of the sun just long enough for humanity to catch a glimpse. 3i Atlas had been one of those rare moments of clarity. Even as the object travelled outward, the simulations tracking its motion grew more refined. Astrophysicists mapped its eventual trajectory through the galaxy, not precisely but directionally. They found that 3i Atlas was headed toward a region between spiral arms, a quiet segment of the Milky Way where stars are sparse and space is wide, a place where gravitational tides are gentle and objects can drift for millions of years without encountering much at all. That empty region will become 3i Atlas's home for a long time, not a resting place. Comets do not rest, but a lull in its journey. There, in that quiet interarm space, the object would cool further, stabilizing into the faint equilibrium it maintained for most of its existence. Any residual warmth absorbed from the sun would dissipate. The dust left on its surface would settle into stillness. It would once again become a dark, silent speck drifting through a place so cold and empty that time itself feels different. But emptiness, in the cosmic sense, is not the same as nothingness. Even in the vast stretches between spiral arms, the interstellar medium flows. Electrons drift. Magnetic fields ripple. Shockwaves from distant stars travel outward like ancient echoes, and every particle, every whisper of force, shapes the objects that drift through these regions, even if only subtly. 3i Atlas will feel those whispers, not enough to change it dramatically, not enough to awaken it, but enough to nudge it gradually across the slow currents that thread the galaxy. And then, perhaps tens of millions of years from now, 3i Atlas will approach another region of denser space, another spiral arm, another star field where newborn suns ignite their disks with blazing heat, another environment where the chemistry that has been frozen within 3i Atlas for eons will once again begin to shift. If the object wanders close to a star bright enough, the outer layers will warm, and perhaps, in another sky, under another sun, a pale coma will begin to form again, and if beings exist there, watching their own night, perhaps they will wonder about the faint visitor that breathes softly in their sky. Perhaps they will ask the same questions we asked. Perhaps they will wonder whether this traveller carries the memory of a world far away. They will not know that 3i Atlas once passed through our system, just as we do not know whether it passed through any other systems before reaching ours. The galaxy does not preserve memories in human terms. Its stories are written in fragments, carried across unimaginable distances, revealed only by chance. Astrobiologists reflecting on the dust 3i Atlas left behind began considering a subtle question. If material drifts between stars in this way, how often do these fragments contribute to the chemical evolution of planetary systems? How often do they deliver molecules, patterns, or structures that trigger new reactions on young worlds? Not life, not directly, but precursors, foundations, raw ingredients shaped by stars unlike our own. This was one of the most humbling realizations of all. Life may not emerge in isolation, not because it spreads from star to star, but because the material that becomes life may be carried by objects like 3i Atlas, tiny travellers delivering chemical possibilities wherever they drift. If true, then the galaxy might be filled with worlds that share fundamental building blocks, not because they share a common origin, but because they share the galaxy's slow exchange of material. 3i Atlas's dust was a small part of that exchange, microscopic, insignificant in mass, but significant in meaning. And as researchers reflected on this quiet idea, a new appreciation formed, not for the comet itself, but for the movement of the galaxy. A movement so slow, so patient, so ancient, that humanity had never noticed it until now. A movement driven not by stars alone, but by everything they release. Planets crumble, moons crack, comets shatter, and their fragments become wanderers, carried by tides across the spiral arms. Someday, perhaps far in the future, fragments of our own solar system, pieces of worlds long gone, may drift into the sky of another civilization, another consciousness looking upward. And they may wonder about the pale dust glowing softly under their sun. 3i Atlas reminded us of this continuity, not by intention, but by example. Meanwhile, a deeper study of the object's composition revealed something unexpected. 3i Atlas's unusual CO2 dominance suggested it originated from a disk richer in carbon than ours. This supported theories that some stars form in environments with dramatically different chemical balances. In such places, carbon-based ices can dominate over water ice, creating comets with entirely different internal structures. This meant that 3i Atlas was not simply a relic. It was evidence of diversity in planetary formation on a galactic scale. Every time we study interstellar material, we add a new piece to the puzzle of how worlds form around different stars. Some systems may produce water worlds. Some may produce carbon-rich environments. Some may produce planets with chemistry unimaginable to us. 3i Atlas was a whisper from one such world. Not a direct message, not a blueprint, but a fragment of its earliest moments. This fragility, this delicacy, this quiet movement of ancient material became the defining theme of 3i Atlas's legacy. People expected interstellar visitors to be dramatic, bright, alarming, spectacular. But 3i Atlas had shown the opposite. The galaxy communicates in whispers, not shouts, not explosions, but slow, soft drifts of material older than entire civilizations. 3i Atlas had not changed its course for us. It had not slowed. It had not noticed our existence. But we noticed it. And in noticing it, something changed. We understood that the universe is alive with motion that continues whether or not anyone is watching. Even now, as the object drifts deeper into the dark, its legacy remains woven into our understanding of where we live. It reminded us that the solar system is not a sealed bubble. It is a doorway, a porous boundary, a place where the galaxy enters occasionally in the form of a faint ancient visitor, and the next visitor may already be near. Not yet bright enough to detect, not yet warm enough to breathe, but drifting silently with the same inevitability that carried 3i Atlas into our sky. One day it will brighten. One day it will awaken. One day it will reveal its own history, a history written under another sun, and humanity now aware will be ready. Not with fear, not with urgency, but with the quiet curiosity sparked by 3i Atlas's passing. Because we now understand, we are not observers of the universe. We are participants in its endless story, a story written in dust, light, motion, and time. Even as 3i Atlas receded into the invisible gulf beyond the heliosphere, its presence continued shaping the way scientists and quiet night watchers imagined the galaxy. It had become less a comet and more a reminder that the universe is not still, that the darkness is not empty, and that the sun is not alone in the quiet sea of drifting fragments. The object itself had vanished from every instrument, but its absence carried weight. It felt like the echo of something ancient passing out of a room, leaving the air subtly changed. Researchers found themselves returning to its data almost compulsively, not out of necessity, but out of a strange affection for the only interstellar object humanity had ever been able to study so clearly. They weren't chasing discoveries anymore. They were trying to understand something deeper, what it means for a star system to be open, what it means for our neighbourhood in the galaxy to have visitors at all. In the silence 3i Atlas left behind, a new kind of astronomy emerged, one centred not solely on gravity or light, but on history, cosmic history, the slow, patient exchange of material between suns. 3i Atlas wasn't merely a body that entered our system. It was a proof that our system is part of a larger circulation, a circulation as natural as ocean currents, as ancient as the galaxy itself. And slowly this understanding began to transform the way scientists saw even the most familiar objects. The asteroid belt, once thought of as a closed agricultural field of local debris, began to be reimagined as something more porous, something that may, over billions of years, have been seeded by fragments just like 3I Atlas. The Oort cloud, long believed to be a reservoir of ancient solar material, was reconsidered as a potential meeting ground for local and interstellar objects, a place where comets from different origins may pass each other silently in the dark. 3I Atlas gave shape to these imaginations, not as a myth, not as a symbol, but as a physical reality that had drifted across the sun's inner chambers without ever attempting to stay. As astronomers continued to map its outbound trajectory, they noticed something subtle, a tiny variation in its path caused not by gravity alone, but by the faint drag of solar particles still reaching beyond the termination shock. The effect was minuscule, but meaningful. It showed that even the most distant edges of the heliosphere interact gently with objects moving through them. This interaction allowed scientists to refine models of the heliosphere's outer shape, a shape influenced by the solar wind, the sun's magnetic cycles, and the constant pressure of the interstellar medium. 3I Atlas had traced that boundary like a fingertip brushing the edge of a curtain. Even now, weeks after disappearing, its trajectory allowed researchers to reconstruct the details of that boundary with unprecedented accuracy. In this sense, 3I Atlas became something more than a visitor. It became a collaborator, an accidental probe mapping regions we have never reached. The next step was even more surprising. A deeper analysis of the dust grains carried by 3I Atlas revealed chemical ratios that didn't match any objects formed near stars rich in heavier elements. This meant that 3I Atlas's home star was likely metal poor, an older star perhaps ancient even among the thick disk. Such stars form early in galactic history, before later generations enriched the galaxy with heavier materials. If this was true, then 3I Atlas wasn't just older than Earth. It may have formed around a star older than the Sun's entire stellar neighbourhood. This reframed everything. Scientists began to imagine 3I Atlas not as a fragment of a young system, but as a fossil, a remnant of ancient galactic epochs, a piece of the early Milky Way, survivor from an era closer to the galaxy's primordial past than to its present. In that interpretation, 3I Atlas wasn't merely carrying the chemical memory of another system, it was carrying the chemical memory of another time. This revelation resonated deeply among astrochemists. They realized that 3I Atlas's dust wasn't just unique. It might be one of the oldest intact chemical samples humanity had ever measured. Not millions of years old, but perhaps billions, untouched since the galaxy's early days, preserved in layers of cryogenic ice until a chance encounter with our sun warmed it enough to reveal itself. That warmed layer, the thin boundary of sublimated CO2 and dust, had carried information from before Earth existed, before any planet existed, before our sun had even ignited. 3I Atlas had crossed light years not just in space, but in time. The idea of encountering something so old, so unchanged, so quietly ancient, stirred a kind of reverence in those who studied it. A reverence not of mysticism, but of scale, an appreciation for the deep time processes that shape the galaxy. Processes that unfold not over centuries or millennia, but over cosmic epochs humanity cannot fully imagine. This reverence shaped new questions, not about 3I Atlas, but about ourselves. What will become of the sun's fragments after our star dies? Will pieces of Earth drift through the interstellar medium someday, as 3I Atlas drifted to us? Will another civilization, if such things ever exist, wonder about a fragment from our long-dead system as it passes their star? Will they see the faint signature of water or carbon or oxygen, and know in some deep way that the fragment belonged to a solar system where life once emerged? 3I Atlas gave shape to these thoughts, not with answers, but with possibility. Meanwhile, more subtle discoveries emerged from the data. Spectral analysis showed that some of 3I Atlas's deepest ices contained isotopic signatures suggesting they formed in a region of space with a different cosmic ray environment than ours. That environment could only exist around a star with a stronger magnetic field or in a region influenced by a recent supernova. This meant 3I Atlas may have been shaped by the dying echoes of a star's explosion, its outer layers bombarded by waves of particles that left chemical scars preserved for ages. To hold such material, even indirectly, was profound. It meant 3I Atlas carried the signature of a star's death, a blast wave that swept through a region of space before Earth existed, and somehow that fragment drifted all the way into our sky. As researchers explored these implications, the public fascination with 3i Atlas also grew, not in dramatic ways, but in small, quiet ones. People found themselves imagining the journey of this ancient traveller, visualizing it moving through spaces so vast and empty that time itself felt thin. They wondered about the origin of its chemistry, the silence of its motion, the cold endurance of its journey. For many, 3i Atlas became a symbol of patience, of slow, inevitable movement through environments that transform objects not by force, but by duration. Human life is short, human history is brief, human memory is fragile. But 3i Atlas existed outside all those constraints. It lived on a scale where millions of years were simply intervals, where stars came and went, where worlds formed and vanished, where dust drifted in patterns shaped by forces older than the galaxy's spiral arms. In that sense, 3i Atlas didn't just expand our scientific understanding, it expanded our emotional understanding of time. And as weeks passed and the object drifted farther into the invisible dark, a quiet awareness settled over the researchers who had followed its passage. They knew they would never see it again. They knew the instruments would never detect another signal. They knew the faint trace of CO2, dust, sodium, and ancient ices would never touch sunlight in our system again. But they also knew something else, something that felt comforting, even grounding. 3i Atlas will continue, quietly, unnoticed, but with purpose embedded in its existence alone. It will drift through the galaxy long after humanity is gone, long after Earth changes in ways we cannot predict, long after the Sun leaves its main sequence stage and transforms into something new. And even then, even after all that, 3i Atlas will still be moving, not because it seeks anything, not because it carries a message, but because motion is the nature of the galaxy, because the stars themselves drift, and everything they release drifts with them. We are made of such fragments. We are shaped by such motions. We are the beneficiaries of countless ancient drifts we will never see. And in the quiet arc of 3i Atlas through our sky, we caught a glimpse of the larger story. The story of a galaxy in slow, eternal motion. A story we belong to, whether we realize it or not. In the months following 3i Atlas's departure from observable space, something began to shift quietly in how humanity thought about the universe. The comet itself, now far beyond the heliosphere, drifting again through the thin, cold current of the interstellar medium, no longer produced any measurable light. But the idea of 3i Atlas remained luminous. It lingered in the consciousness of those who had followed its brief illumination, shaping new questions and new perspectives. Some scientists found themselves returning to their desks late in the evening, not because new data had arrived. None would ever arrive again. But because the questions 3i Atlas raised had a way of circling back at unexpected moments. They would pull up its spectral readings, its rotational measurements, its outgassing curves. They would stare at the line graphs, the CO2 ratios, the narrow sodium signatures, as though the object might still whisper something they had missed. Some even confessed that looking at the data felt like looking at the last photograph of someone they once knew. Not sentimental, not emotional, but reflective, heavy with the awareness that a moment had passed that would never occur again. 3i Atlas was a transient visitor, but it left a permanent shift. At the core of that shift was a single realization. The galaxy is full of such wanderers. Our solar system is not a closed vessel, not a sealed-off bubble floating alone. It is more like a harbour, the mouth of a coastline where pieces of the greater ocean occasionally wash in. Some drift back out, some dissolve, some reveal themselves briefly before fading again. 3i Atlas was one of the few we noticed, not because it was rare, but because we are finally learning to see. And once you see something like 3i Atlas clearly, once you understand what it represents, the universe begins to look different. One of the profound realizations came from the chemical diversity 3i Atlas displayed. Its dominant CO2 signature contrasted sharply with the water-rich nature of most comets formed near stars like ours. This difference implied that planetary systems across the galaxy are incredibly diverse, each with its own chemical fingerprint, its own ice lines, its own volatile reservoirs. 3i Atlas was a reminder that our solar system is not a template. It is merely one example among countless possibilities. Some stars may form comets rich in methane. Others may produce ammonia-dominated objects. Some may develop ices made from exotic compounds rarely seen near our Sun. 3i Atlas was one sample from this cosmic spectrum, a physical piece of a world we could never visit, drifting into our awareness for a brief and quiet moment. For scientists studying planetary formation, this was exhilarating. But for others, especially those who watch the sky for reasons more personal than scientific, 3i Atlas offered something different. It offered a sense of connection to the broader galaxy, a feeling that the stars are not remote landmarks, but participants in a shared exchange of matter. Even the dust 3i Atlas left behind, now drifting in tiny quantities through the solar system, contributed to this sense of connection. Over time, those grains will migrate into different orbits. Some may be pulled inward by subtle forces, eventually falling toward the Sun. Some may drift outward, slipping into the Oort cloud before being nudged into new trajectories by passing stars. And a few, maybe only a handful, may eventually intersect Earth's orbit. If they do, they will enter our atmosphere silently, burn up gently, disappear without notice. Yet their existence will have meaning, even if no one ever sees them, because they will be the final traces of an interstellar traveller, returning to starlight after millions of years in darkness. This realization prompted a series of philosophical questions that moved through scientific circles quietly, like a tide that no one quite acknowledged but everyone felt. Questions about how many such fragments fall into Earth every century, how many microsignatures of alien star systems lie hidden in our sedimentary layers, unrecognized among local grains. How many planetary stories might already be mixed into the dust beneath our feet? Not stories of civilizations, not stories of life, but stories of formation, stories of chemistry older than the continents. 3i Atlas awakened the idea that Earth is not separate from the galaxy, it is nourished by it. Meanwhile, the astrophysical community turned its attention to the broader implication. If 3i Atlas is representative of interstellar comets, then the galaxy may be exchanging materials constantly, shaping the evolution of new star systems over time, not intentionally, not through design, but through drift, through the slow, patient movement of debris released by planets and comets across billions of years. This raised a possibility too intriguing to ignore. Could the early solar system have been seeded with interstellar material? Not necessarily life, but organic precursors, volatile ices, molecular patterns inherited from neighbouring stars. If true, it means Earth carries within it not only the story of our Sun, but the stories of stars that never touched our sky. 3i Atlas made this more than speculation. What fascinated scientists most was the object's endurance. Despite drifting through the galaxy's harshest environments, despite exposure to cosmic rays and interstellar dust collisions, 3i Atlas arrived in our system still intact, still active, still able to release a coma so large that it dwarfed Earth's orbit in scale. This endurance implied that many interstellar objects may survive long journeys without disintegrating, waiting silently until they pass close enough to a star to awaken. This led to another question, one that stirred both excitement and contemplation. What if the galaxy is filled with objects just like 3i Atlas, drifting invisibly through the dark, awaiting the warmth of any star to reveal themselves? Some may never find such warmth. Some may drift forever, forgotten by the systems they once belonged to. Others may pass near stars but remain undiscovered, glowing too faintly for too short a time to be noticed. 3i Atlas, then, was not a singular miracle. It was a representative of a phenomenon far larger than we imagined. And in that realization lay a quiet sense of belonging, not just for scientists, but for everyone who felt even a small spark of wonder hearing about the comet's journey. It meant that our solar system, with its planets and moons and rings and belts, is not isolated. It is part of a galactic neighbourhood where material flows freely, crossing from one system to another in gentle, ancient migrations. On a deeper emotional level, 3i Atlas reminded humanity of something often forgotten, that curiosity is one of our most natural responses to the universe. That wonder is not childish. It is the beginning of understanding. That mystery is not something to fear, but something that calls us to look beyond ourselves. 3i Atlas did not speak. It did not communicate intentionally. It did not reveal secrets in the human sense. But it invited us, quietly, to broaden the way we see. Its silence became a form of teaching. Its motion became a form of storytelling, and the story it carried was simple, yet profound. Everything is moving. Everything is connected. Everything is older than we think. Even now, as the object drifts further into the deep, cold dark, its trajectory holds the memory of our system, a faint imprint of solar warmth, absorbed during its brief approach and now radiating outward into the interstellar medium. That warmth will fade, molecule by molecule, but it will linger for decades, a small echo of the sun carried across the galaxy by a fragment older than the sun itself. In that sense, a piece of the sun continues travelling with 3i Atlas, not in substance, but in memory, the memory of heat, the memory of light. And as the decades turn to centuries and centuries turn to ages, 3i Atlas will continue drifting, unchanged in purpose but continually changing in place. It may never approach another star closely enough to awaken again. Or it may. The galaxy is unpredictable on such timescales. But whether it glows once more or remains forever silent, its journey will not end. It will move through the galaxy long after humanity's story has transformed beyond recognition. Long after Earth has shifted beneath the weight of geological ages. Long after the sun begins to dim into its final stages. And even then, long after, 3i Atlas will still be carrying the faint signature of our star, added to the deeper, older memories in its ancient core. In this way, the comet did something remarkable. It reminded humanity that we too are travellers, our lives short, our time brief, our awareness young, but our participation in the universe inevitable. We live under a star that breathes, on a world that drifts, in a galaxy that exchanges its history through fragments like 3i Atlas. And because we noticed one of those fragments, because we studied it, listened to it, wondered about it, we now understand our place a little more clearly. The universe is vast, but it is not foreign, it is not distant, it is not silent, it is full of motion, motion that sometimes brings ancient travellers into our sky for the briefest flicker of time. 3i Atlas was one such flicker, and its light, though soft, though fleeting, will echo through our understanding for generations. As the last trace of 3i Atlas dissolved into the distant dark, its influence remained, not as a visible object or a measurable signal, but as a presence woven delicately into the way humanity now thought about the universe. In the weeks and months after its departure, there was a quiet shift among those who had followed its path. The comet was no longer a subject of study. It had become a point of reference, a reminder of how incomplete our understanding of the cosmos still is, and how much of the galaxy's story drifts silently through the spaces between stars. One of the most subtle changes occurred not in scientific journals, but in the minds of observers. People began to look at the night sky differently. The familiar constellations, Orion, Cassiopeia, Cygnus, no longer seemed like static paintings. They began to feel like windows into something deeper, darker, more alive. A system of distance, yes, but also a system of motion. A place where even the faintest star might be shedding fragments that, given enough time, could drift into our own system the way 3i Atlas had drifted into theirs. And in that view, the universe began to feel less like a remote spectacle, and more like an environment, one that humanity is slowly learning how to inhabit. Even those who spent their lives studying planets and moons admitted they had never thought much about the space between stars. That void had always felt irrelevant, a background, a nothingness. But 3i Atlas changed that. It turned the void into something textured, dynamic, and filled with invisible motion. It made people understand that the interstellar medium is not emptiness, but the galaxy's bloodstream, and objects like 3i Atlas are the cells drifting through it. This shift in perception influenced research in quiet but profound ways. Teams studying exoplanets reconsidered how material from other systems might interact with planetary atmospheres. Astrobiologists revisited theories about the origins of prebiotic chemistry. Stellar evolution experts rethought how supernova ejecta contributes to the distribution of solid fragments over galactic timescales. In each field, 3i Atlas was not a central topic, but it was a reference point, a reminder, a quiet undercurrent shaping new questions. One of the questions that emerged most often was surprisingly personal. How many interstellar objects have visited Earth without our awareness? Not large objects, those would leave scars in geological layers, but microscopic ones. Dust, grains, tiny flecks travelling between stars, drifting unnoticed into the atmosphere over billions of years. If 3I Atlas left behind dust that would remain in our system for centuries, then perhaps Earth has been collecting such grains since its formation. Perhaps some of the particles embedded in ancient rocks came from stars whose light faded long before Earth cooled. The idea that fragments of other worlds might already be part of Earth's history brought comfort to some people, a sense of connection, of shared cosmic heritage. To others it brought perspective, reminding them that humanity's origins are not isolated. They emerge from a long chain of events shaped by forces far beyond our comprehension. But where most saw meaning, scientists saw opportunity. 3I Atlas had shown that we can identify interstellar chemistry with precision. We can distinguish the isotopic fingerprints of different stellar environments. We can trace the carbon ratios of regions where water ice barely forms. This meant that if Earth does contain grains from other worlds, we now have the tools to find them. Perhaps not easily, perhaps not soon, but eventually, with enough patience, with the right instruments, with the same quiet curiosity that led us to study 3I Atlas in the first place. As the months passed, the story of 3I Atlas continued to deepen in unexpected directions. One research team analysed the subtle changes in the object's velocity as it approached and then receded from the Sun. Though minuscule, these changes offered insight into the internal makeup of the nucleus. Comets from our system often exhibit erratic thrust as volatiles escape, but 3I Atlas had been steady, unusually steady. This stability indicated a nucleus with fewer fractures and a more uniform structure. It suggested that whatever process formed 3I Atlas had produced a body with remarkable cohesion. Such cohesion hinted at a formation environment with low collision rates, a calm disk perhaps, or a region shielded from turbulence by magnetic fields. This in turn implied that the object's parent star may have experienced a quieter early life than our Sun. Not all stars have violent beginnings. Some ignite gently. Some accumulate their material without intense shock waves. Some form planets and comets in peace. 3I Atlas, then, may have been born in peace, before drifting into endless wandering. This detail, though small, added a layer of poignancy to the object's story. It suggested that the fragment which had passed briefly through our sky was not the product of chaos, but of calm. A remnant from a system that began quietly, perhaps beautifully, under a soft and ancient light. And yet that light had long since faded from 3I Atlas's memory. Another research team focused on the sodium emission detected near perihelion. Sodium signatures in comets can reveal heating cycles. How deeply sunlight penetrated into the nucleus, how old the exposed layers are, how recently those layers formed. In 3I Atlas's case, the sodium came from deeper strata than expected, which indicated that even after millions of years of drifting, the comet's outermost layers had remained intact enough to preserve ancient material. This preservation was astonishing. Local comets lose layers quickly. Every close pass strips off meters of material. But 3I Atlas had never experienced such frequent heating. It may have awakened only a handful of times over its entire existence. This meant the sodium, the CO2, the dust, all of them were messengers not merely of another system but of another era. 3I Atlas had carried untouched material from a time so ancient that no planets had yet formed in our solar nebula. Holding that in digital form, even in data alone, felt like holding a fragment of the galaxy's earliest chapters. As discussions spread across disciplines, something else became clear. 3I Atlas didn't just change what humanity understood, it changed what humanity expected. Before 3I Atlas, interstellar visitors were curiosities. Now they were inevitable, expected, anticipated. Astronomers began preparing new search algorithms specifically designed to identify faint interstellar objects earlier. The next generation of wide-field sky surveys would incorporate 3I Atlas as a reference case. Future telescopes would be calibrated with interstellar detection in mind. Proposals emerged for missions positioned far beyond Jupiter, ready to intercept the next object before it slipped away. All of this, the planning, the imagining, the quiet excitement, stemmed from the soft, pale glow of one ancient traveller, But perhaps the most profound shift occurred not in the instruments or in the algorithms, but in the quiet mental space of those who reflect on these things late at night, when the world is still. They thought about 3i Atlas drifting through a darkness deeper than language can express. They imagined it passing near stars that flickered and died long before the sun was born. They pictured it surviving storms of radiation that would obliterate fragile machines. They saw it carrying the quiet memory of its origin across distances so vast that human numbers lose meaning. And for the first time, many people realize that the galaxy is not made only of stars and planets. It is made of wanderers, silent, ancient, patient, persistent. 3i Atlas was one such wanderer, a single fragment of cosmic time, a reminder that nothing in the universe is ever truly still. Even now it continues outward, a dark speck carrying the faintest trace of sunlight absorbed during its brief encounter with our star. That warmth will fade, but not immediately. For decades, 3i Atlas will radiate the last whisper of our sun back into the cold sea between stars. In that sense, 3i Atlas carries a memory of us, not of humanity, not of Earth, but of our star's touch. And someday, perhaps in a distant future we will never witness, another being under another sky may notice a faint glow, trace the object's path, and wonder about the star whose warmth shaped it long ago. They will not know our name, they will not know our world, but they will know the sun, because 3i Atlas carries a piece of its story, and in that exchange, in that quiet transfer of memory between systems, the galaxy reveals itself as something far more connected than we ever imagined. 3i Atlas is gone, but its journey continues, and its legacy, a moment of cosmic clarity, remains with us, gently widening our sense of where we belong. As 3i Atlas drifted into regions where even sunlight became little more than a memory, its influence on humanity deepened in a way no one had expected. The object itself had become invisible, not just to telescopes, but to any perception tied to light. Yet its departure marked the beginning of something far larger, a transformation in how we understand our place in the galaxy. It was almost paradoxical. The moment it vanished was the moment its meaning became clearest. Because 3i Atlas had shown us something unmistakably simple and deeply profound. The universe is not a silent expanse of isolated stars. It is an ecosystem with a circulation all its own. And humanity, barely stepping beyond its homeworld, had caught its first glimpse of that circulation. Astronomers began to study the interstellar medium not merely as a backdrop, but as a living environment, a place where particles, fields, and ancient fragments flow in currents shaped by the galaxy's rotation. 3i Atlas had traced one of those currents, not intentionally, but faithfully. It had drifted through the interarm regions, through the magnetic folds of the thick disk, through radiation storms left behind by supernovae that exploded before Earth existed. It had survived those forces, carrying with it a record etched into its chemistry. When scientists examined that record, they realized it was unlike anything found in the solar system. The carbon-to-oxygen ratios didn't match local compositions. The sodium emissions came from layers untouched by sunlight for millions of years. The ultrafine dust grains, smoothed by eons of microcollisions, revealed the fingerprint of the interstellar plasma environment. All of these details formed a story that wasn't merely scientific, it was historical. A story written not by consciousness, but by time. And that's what made 3i Atlas so extraordinary. It carried a history older than the sun, yet it delivered that history so quietly. For many, the quietness was what made it beautiful. Meanwhile, astrophysicists ran simulations to estimate how many similar objects might be drifting through the galaxy at any given moment. The results were staggering. For every 3i Atlas we detect, there may be millions we never see. Fragments wandering through the darkness, some the size of houses, some the size of mountains, all moving in silence. These objects are not rare. They are abundant, part of the natural debris produced as stars form, evolve, and eventually die. 3i Atlas was just one of these countless wanderers, but it was the one we happened to notice. Some teams proposed that interstellar objects might play a surprisingly important role in shaping the chemistry of young star systems. When stars collapse from vast clouds of gas and dust, they rarely form in isolation. They form in clusters, they share their material. And over millions of years, fragments like 3I Atlas drift from one cluster to another, carrying with them atoms and molecules forged under different conditions. These fragments might seed young systems with new chemical ingredients, influencing the diversity of planets that eventually form. If this is true, then our solar system may contain material not only from the Sun's birth cloud, but from long-dead stars that lived and died before our own existed. And perhaps, in this grand exchange, the early Earth received dust that drifted here just as 3I Atlas drifted toward us. Dust that carried unique chemical combinations. Dust that, under the right conditions, contributed to the long chain of reactions that eventually produced living cells. Life on Earth may have been shaped by wanderers we will never know. This idea did not diminish humanity's significance. It expanded it. It placed Earth's story within a larger tapestry. A tapestry woven not just from local events, but from the silent contributions of distant stars. And as scientists continued tracing the implications of 3I Atlas's chemistry, a new thought emerged. If our solar system has always been open to fragments from elsewhere, then our own system's debris must also be drifting outward into the galaxy. In other words, someday, perhaps millions or billions of years from now, fragments of our sun, of our planets, of our comets, may drift through the sky of another civilization. Imagine that. Imagine a distant world orbiting a star we will never see. Imagine beings, whatever form they take, looking up and noticing a faint pale glow moving across their night. Perhaps they will detect CO2. Perhaps they will detect water ice. Perhaps they will detect traces of metals forged in our sun's core and carried outward by stellar winds. And perhaps they will wonder where this traveller came from, what system shaped it, what star once warmed it, what story it carried. They will not know us. They will not know our world, but they will know our sun, because a fragment of it drifted across their sky. This exchange is not poetic fantasy. It is the natural behaviour of the galaxy. 3I Atlas simply made us aware of it. One of the most unexpected outcomes of 3I Atlas's passage was its emotional impact on people who typically think of astronomy as distant or abstract. Many described feeling a strange mixture of humility and comfort. Humility at the scale of the universe, comfort in the realization that we are part of something larger, something ancient, something quietly interconnected. It is easy to think of the galaxy as an indifferent expanse. 3I Atlas revealed the truth. The galaxy is a place of continuous sharing. Its stars breathe out dust and ice. Its planets shed fragments during collisions. Its comets are cast out by gravitational tides. These fragments drift, mix, accumulate, dissolve, and reform in new systems. The galaxy is not indifferent. It is alive with exchange, and humanity, for the first time, saw this exchange clearly. Even now, long after 3I Atlas has faded into the cold beyond the heliopause, its dust remains within the solar system. Some of it, pushed outward by the solar wind, drifts in thin arcs beyond Neptune. Some of it, pulled by gravity into slower orbits, circulates among the planets. Some of it, so small it floats like pollen in sunlight, glimmers faintly in the zodiacal light, the pale band that stretches along the ecliptic at dawn and dusk. When people see that light, they rarely think about its origins. They see a glow and assume it belongs to the solar system alone. But now we know better. Some of that glow, however faint, however immeasurable, belongs to 3I Atlas. And this realization changes something subtle about how we see even the most familiar sights. It turns the zodiacal glow into a symbol of connection, a reminder that our sky is not purely our own, a reminder that somewhere, drifting invisibly among local particles, are grains that began their journey under another sun. Scientists estimate that those grains will remain in the solar system for centuries, possibly millennia, before radiation pressure nudges them outward, carrying them back into the interstellar medium. When they leave, they will carry with them the faint chemical imprint of our sun, absorbed during their time in its light. In this way, 3I Atlas does not merely carry our sun's memory out into the galaxy. It sends that memory outward through countless small particles, each one a messenger of quiet exchange. This is what moved people most, the idea that nothing in the universe truly stands alone, not stars, not planets, not fragments, not even us. We exist within a web of interactions that stretches across the Milky Way. Most of it is invisible, most of it is slow, most of it we will never witness directly, But 3i Atlas revealed enough for us to understand. We are part of a galaxy that breathes, and in that breathing, in that slow migration of ancient fragments, the universe writes its story. 3i Atlas was one sentence in that story, but its meaning will linger for generations, quietly expanding the way we understand distance, time, and our own place among the stars. As 3i Atlas continued its silent journey into the deep, cold dark, beyond the reach of any star's warmth, it became something more than an object of study. Over time, slowly, quietly, it became part of the mental landscape of how we imagine the universe. The comet's physical body had long vanished from our instruments, but its presence lingered in the space it left behind like a fading echo that refuses to disappear. It was strange to think that something so small, a fragment drifting across the void, could shift the way an entire species understands the galaxy, and yet 3i Atlas had done exactly that. Not through power or spectacle, but through the delicate truth of its existence. It revealed that the universe is not a collection of isolated systems, but a dynamic web of wandering fragments and drifting histories. Every time astronomers revisited the data, this truth became clearer. 3i Atlas was more than ancient, it was ancestral. A traveller shaped by the earliest eras of galactic formation. A relic forged in a world older than our sun, older than our system, older than any planet we can study directly. And the fact that humanity witnessed its brief awakening, that we saw its gases glow, its coma expand, its tail respond to the solar wind, felt less like coincidence and more like a reminder. A reminder that the galaxy contains stories older than civilization, older than biology, older than language. 3i Atlas was one of those stories, a quiet chapter drifting across billions of years. When the final analysis of its dust composition was completed, scientists discovered something they hadn't expected. The distribution of grain sizes suggested that 3i Atlas had been shaped in a disk with unusually gentle turbulence. In such an environment, particles settle, layer, and compact without violent collisions. This finding implied that 3i Atlas's parent system may have been unusually calm, not chaotic like the early solar system, but serene, almost sheltered. It is a strange feeling to imagine serenity in the birth of a world, to imagine a star forming softly, gathering its disk in quiet spirals, allowing comets to form gently at distant ice lines. 3i Atlas was likely one of those gentle beginnings, a fragment that never fully grew into a world, but instead drifted outward before its system matured. And from that early moment, long before Earth existed, 3i Atlas began its slow voyage, drifting through the galaxy's magnetic tides, passing through the chemical winds of supernova remnants, threading silently between the bright arms of the Milky Way, carrying with it the chemistry of a star we will never know. If not for a chance alignment, a soft gravitational nudge from a passing star perhaps, the comet might never have approached our sun. It might have continued drifting forever in the cold between stars, unseen by any civilization. But it did not. It wandered into our sky, and that single moment of illumination revealed truths that were otherwise inaccessible. It revealed that interstellar objects are common, not rare. It revealed that the galaxy is constantly exchanging its material. It revealed that chemical diversity across star systems is far greater than we imagined. It revealed that history in the cosmic sense is not bound to one world. And more than anything, it revealed that the universe is patient. 3i Atlas had travelled for millions of years. Humanity had been looking for objects like it for barely a century. The moment we became capable of noticing such travellers, one arrived. This timing, though random, felt almost intimate. A reminder that even in its vastness, the universe still offers opportunities for discovery when we are ready to see them. As the comet faded into deep interstellar space, its dust trail inside the solar system continued to disperse. Some grains moved outward, some inward, some remained in gentle elliptical orbits for decades. These grains, fragile, microscopic, ancient, became quiet messengers of a star we will never visit. They mixed with local dust, drifting through the zodiacal cloud, becoming part of the faint band of light that humans have seen since prehistory without ever knowing its origins. Now we know, a few of those grains came from 3i Atlas. It's humbling to think that at dawn or dusk, when the sky glows faintly along the ecliptic, some of that glow belongs to an interstellar wanderer that crossed our system once and will never return. Light from our sun reflecting off dust born under another star. Dust sculpted by a journey older than all of human memory. Even after 3I Atlas fully vanished from our instruments, scientists continued simulating its distant future. The model showed that it will enter a region of deep interarm space where gravitational forces are gentle and the interstellar medium is thin. There, it will drift for ages. Nothing will warm it. Nothing will change it. The fragment will continue, not in a line, but in a long wandering arc across the galaxy. And after millions of years, perhaps after our sun has burned for epochs beyond human presence, 3I Atlas may enter another stellar system. If the conditions are right, it may awaken again. Its ices may warm, its coma may expand, and a pale glow may appear in the sky of another world, alerting whoever lives there, if life exists, that a visitor from far away has arrived. They will not know our star by name. They will not know that Earth once existed, or that humans once watched 3I Atlas move silently through their own night. But they will know that this visitor carries chemistry that formed under a distant sun. They will know that its dust is ancient. They will know that its warmth is borrowed from places unknown. And in that moment, long after we are gone, 3I Atlas will continue doing what it has always done, carrying the galaxy's stories across the dark. The truth is, the universe does not preserve history the way we do. It does not keep records or monuments. It does not build archives. But it does carry fragments, small, ancient, wandering fragments, that drift between stars and reveal pieces of the past to any civilization capable of noticing them. 3I Atlas was one such piece, a page from a book written before our world began. And for one quiet moment in the vast timeline of the cosmos, that page passed close enough for humanity to read. When people look back on this era of discovery, they may forget the technical details, the spectral lines, the isotopic ratios, the rotational data. They may forget the exact date of the comet's closest approach. They may forget the instruments that captured its fleeting glow. But they will remember the sense of perspective it brought. They will remember that once, a fragment from another star drifted into our sky. They will remember that the galaxy is alive with motion and history. They will remember that Earth is not separate from that story. It is woven into it. And perhaps that is 3I Atlas's greatest gift to us. Not its data, not its chemistry, not its orbit, but its reminder that we are part of something vast, patient, and interconnected. Something ancient, something ongoing, something shared. Even now, as 3I Atlas drifts farther than any human-built object has ever travelled, its meaning remains close. It reminds us that the universe is not empty, it is not silent, it is not indifferent, it is full of motion and memory and possibility. And every so often, when the timing is right and our attention is open, one of its wanderers passes close enough for us to notice. 3I Atlas was such a wanderer. And though it is gone from our sight, it continues, carrying the sun's final warmth into the cold between stars,